Honorable guests, Your Excellence, ladies and gentlemen, now I also got the text of my speech, part of my speech. Welcome to this conference, which is about cooperation across the Gulf of Finland, not this time along the Gulf of Finland, because out of 3 classic partners, only 2 are today on board. And that's why this conference title is somewhat different from the other titles in this series. We try to think what we have achieved, but even more importantly, to think where and which form could be the future of our cooperation. And the thoughts are that the experience in the Gulf of Finland could be a nucleus important for the rest of the world. And first of all, a nucleus which has experience on transboundary nurture of the marine environment, and this nucleus is in a massive transition today. So we know that the Baltic Sea is kind of small ocean. In terms of level of variability, which is comparable to that of the ocean. And this is the point of the Baltic Earth initiative, which treats the Baltic Sea as a small model and very useful model of the ocean. So the Gulf of Finland could be understood as pointing to the future in terms of a nucleus of things which may happen in the future. I don't have here in mind expansion of military conflicts in the world. I have here in the mind the experience from the Cold War times when science and marine science was one of the channels of science diplomacy. We do have here many things which are interesting to us and possibly instructive to many others. Be it extreme variations in hydrography, salinity from some 15 gram per kilogram down to 0 at the Neva Bight. Be it harsh living conditions for the ecosystem in rapidly changing salinity, both in space and time. So it is harsh for the ecosystem because we know that there is a minimum of variability and richness of ecosystem at some level of salinity. We have extreme variability in terms of appearance and nature of the coasts, from bedrock-based archipelago down to classic sandy and gravel and even muddy coasts in some parts of this water body. The same is for the bottom sediment. Some places are basically void of fine sediments and some places are covered by mud. We have one of the largest level of anthropogenic impacts, be it 3 large rivers which are discharging to the eastern part of this bay. This area is bordered by radically different countries, not in terms of the level of lifestyle, but in terms of thinking about themselves, about the future of the world, and about how to protect the environment, and about whether the environment needs protection at all. So this is not simply interdisciplinary challenge, what we have here in the Gulf of Finland. It should be termed completely different with whatever buzzword is now being used in science administration, be it so-called cross-sectoral or transdisciplinary or even holistic. You say it, it's all applicable. And on top of that, this area has one of the strongest impact of climate change among many regions of the world. For example, the changes in ice regime are the fastest in the world on the latitudes of the Gulf of Finland. And plus, navigation loads and possibility to damage critical infrastructure just by misusing ship anchors. So we are living, in some sense, in the center of the world. And I think that it is our, not challenge, yes, also challenge, but opportunity to share our experience, to spread the word about how such complicated systems can and should be analyzed from scientific viewpoint. Having said that, it's my pleasure to declare this Gulf of Finland and Eastern Baltic Sea Science Days, I stress, and Eastern Baltic Sea Science Days 2023 open. And it's my honor to chair the first session and announcing the first keynote for today, which had a very clear title in the first part of the program, but now it has been changed, maybe because of keynote, to a much more complicated title, Improving Gulf of Finland Wave Forecast and Statistics, given by Hedi Kanarik with many co-authors. Hedi, you're welcome.
How does this system work? Oi. Okay. So, hello everyone. Thank you for inviting me. And here I'm going to talk to you about the work we have done in FMI in improving wave forecast in the Baltic Sea, with a special focus on the Gulf of Finland, of course, and the statistics that we have developed trying to create more and more useful products for the people working at the sea, so that they can use our products well. As this is Gulf of Finland Science Days, I thought it would be fun to start with small facts about Gulf of Finland. This is a very narrow basin that is very limited in the wave growth due to the shape of it. However, it still has very high wave heights in some locations. For example, just a month ago, Estonian wave buoy measured 5.8 meter waves in the western half of Gulf of Finland. But because this presentation is about wave models, I thought it's fun to show you our forecasted model situation here. The extreme value was measured in that X location there. One other fun thing in Gulf of Finland is that the other extremes that we have measured at the Gulf of Finland wave buoy, 5.2 meters, they have occurred in completely different situations, one with easterly and one with westerly winds. So both directions can cause quite high waves in the area. But this is not really the topic of the presentation, so let's go to the main thing. In FMI, we have these two main focuses of the developments on the waves. One is this basin-wide scale that we do together with PALMFC consortium. It's this Copernicus Marine Service called Baltic Monitoring and Forecasting Center, where we, together with Danish, Estonian, Swedish, and German colleagues, developed the ocean models and forecasts in the Baltic Sea region. And big main focus on the wave side right now here is the coupling of the ocean, of our forecast to the ocean ice model. to represent the sea state as accurately as possible. And on the other side, in FMI, we are focusing on improving forecast in coastal archipelago areas, as these are very unique and complex locations in the scale of the whole world. Previously, this work with the archipelago has been focused on the archipelago sea area and the coast of Helsinki, but recently the focus has shifted more towards the more tailored products at the fairway locations. When you think about these two developments in the point of view of Gulf of Finland, then we know that Gulf of Finland is seasonally ice covered, as mentioned before. It occasionally has strong currents and a large shades of the sea surface height variations. And all of these are something that we can get from ocean ice model and include into our wave models to get a bit more accurate results, possibly. And then again, especially the northern half of the Gulf of Finland has very irregular coastline and rugged bottom topography and lots of islands. In the right side, you see the bathymetry used in this fine resolution Helsinki model and the results coming from that. And in the left side, there's a picture of how the wave heights waves have accumulated to the certain areas due to the bottom topography in the archipelago sea region. And this kind of information can be very important for shipping safety or structures if you put, for example, wind power plants into the sea. But the main topic of my presentation is in this basin scale approach, so the coupling between the wave and ocean models, as this is what I have worked myself more with. Currently in this BALAM-FC system, we are running separately this ocean ice model, NEMO SI3. This SI3 is now the IceCamp part, and I don't know the nicer name for it, and then the wave model WAM. They are both forced with the same atmospheric forcing, and then NEMO and WAM are exchanging information with each other offline. Currently, our wave model reads in ice currents and sea surface heights from NEMO, and then NEMO reads in Stokes-Coriolis forcing. And we are right now working on implementing this sea state-dependent momentum flux to our system. However, this is a bit larger task and will require online coupling, so it won't be happening in the next year, or maybe not even on one after that. I thought that I would go through each of these couplings and how they have affected our wave model forecasts. First, we'll start with ice, as this is the single most important factor out of these three that affect the quality of the wave forecasts in the Baltic, as the location of ice affects the areas where the waves can grow. And the most accurate product that we have right now available about the ice conditions at the Baltic are these shear charts that are produced by the ice services in FMI and SMHI. And we use these often when we do analysis back in time, trying to see how the current wave situations have been. However, when you think about making long forecasts, for example, up to 6 days in the future, like we do in the BALAM-FC, then these stationary ice fields might end up being very wrong. And then using ice information from the 3D model might be a better approach, even though these models tend to overestimate ice a bit right now. However, they have added the assimilation of ice to our next product, so I'm expecting that to get better. It's going to be online at the end of this month. So, other side of this are the sea surface currents that we added to the system a few years ago. Overall, the current-induced difference into the wave fields in Baltic Sea is very small. As you know, the currents in the Baltic in general are small, but in some storm situations they can grow to quite large values. And in here, we show you one example of the situation where adding a current field to this wave model has actually improved the model results in Gulf of Finland. This spectra shows the measurements at the Gulf of Finland wave buoy, shown in the arrow in the right. And here we had the strong currents in northern half of Gulf of Finland, and they refracted the long wave as well towards the Estonian coast. So even though these situations are rare, it might be important to take this kind of refraction in account when you think about, for example, coastal structures that are very sensitive to the longer waves, for example. Most recently, we added also sea level variation to the wave model. Same story as with the currents. In general, the effects of sea surface heights on waves in the Baltic Sea is small. However, in coastal regions where we have very shallower areas where the waves actually interact with the bottom, because as the point of the view of the waves, Baltic Sea is still very deep sea in many areas. But in this picture, I show you the largest increase that we saw in the significant wave height and the smallest increase. That's very empty figure, I know. I was wondering why did I even put it here now yesterday when I looked at it. But from this you can see that sometimes when we have higher sea levels in the, for example, at the end of the Gulf, we might get even 1 meter higher waves in the regions where we have very shallow areas that have. Yes, so this kind of approach might be very important when thinking about these extreme cases and the safe sea level of safe building levels in the sea. Now this is what we have done with the wave model, and let's move to the ocean side of the things. We have implemented the Stokes-Coriolis forcing to the NEMO model, and this is the same story as before. The effects are only happen when we have a very stormy conditions where you can actually see differences in the model system. This case is even less often than with the waves. And I must say that one of the reasons why this is added is also that in the Copernicus we want to have very similar models all around the Europe, and the seas are very different. So sometimes we need to add things that don't really make much difference. In this figure, at the very peak, you see the difference caused by the Coriolis forcing in the system. So currently we are working on this sea state-dependent momentum flux. And the thing here is that currently the NEMO calculates shear stress felt by the sea using only atmospheric forcing and does not take account of the sea state. But in the coupled system, the situation would change so that in areas where the waves grow, the ocean model will experience less stress, and the areas where the waves will be breaking, for example, the ocean will see the more stress. So the area where the ocean feels the stress will shift and change. So this is actually causing quite large differences to the wave model. In these pictures, the red values are the ones that have the stress parameter in them, and the bluish-green values are the ones with the Stokes-Coriolis or just nothing in them. So you see the difference is quite huge. There's time series of 2 different locations, and if you look at the one in Hamina, it looks that implementing of this stress parameter actually makes everything much worse. But this is actually more of a tuning issue, as these models have been made to, the main thing of these models is to get the sea level variation correct, as is very much needed for the shipping. And but in the lower figure, you see that during the same event, when we did over and undershoot the sea levels a lot in the Gulf of Finland, we did actually manage to get the sea level better in the Warnemünde region. That is a bit more challenging. So this gives us hope that this might not be a useless task. And with tuning, it might actually give us a nice correction to the whole system. So a little bit about the coastal modeling of Arctic archipelago sea areas. As I said, we have now moved more towards this approach that we go into the certain fairways and work together with the pilots in that area to give them information they need. In this figure, a red triangle shows the location where pilots often embark ships. And as from the right upper right corner picture you can see, this is in this area you can still have quite harsh wave conditions, and they use our forecast to make the decision if they embark the ship or not. And in point of view of me at least, I sometimes just think that, well, big values, high waves, that's the problem. But actually, when talking to the pilots, we have learned that in this area, for example, it's challenging to, the most challenging conditions come with the waves coming from the south, as they go from shallow regions and they're very steep, even though they're not very high. And so we are now working towards taking account this kind of information when we provide products to the ships and the pilots there. On top of these forecast products, we of course calculate the different statistics of the waves, helping people to make decisions on spatial planning on structures at the sea. This is a picture of a traditional statistics, for example, percentiles of the highest waves in the Baltic Sea, and they are very well known in Baltic in general. There has been many studies on this using different atmospheric forcings and so on, and we know that the seasonal variation of waves is very big and important in the Baltic. When we do these kind of products, we use this PalMFC hindcast product. It's a 1 nautical mile, 1 hour time resolution model that is available for everyone. And we are updating it every 6 months from now. And because I'm now here, I have to advertise to you that we are gonna update this product next year using a new version of VAM that is gonna be using ST4 physics. So this is a new source term package of parameterization of dissipation, but parameterization for dissipation of infinite waves. It's actually not that new, but still. And we have seen that, for example, in Gulf of Finland, in the scatter plots, we have been able to produce better peak periods in the Gulf, at least in the Gulf of Finland wave buoy location. Left is the old and right is the new. So wait forward for that. It's gonna be nice, and it's also gonna cover almost 20 more years of data. But more about these statistics that we have been calculated. Together with Natural Research Institute, we were trying to estimate the areas where we could have more fish farms in the coast of Finland. And we did this by looking at the areas where the wave conditions are mild enough, often enough. And this first approach that we had was that we calculated the percentage of days when the maximum significant wave height was below the certain threshold, and then looked at the areas where they were below the certain threshold often enough. For example, for feeding, the significant wave height was okay to be only 1 meter per second, 1 meter, and they had to have that at least 70% of the time. The feeding season, or the growth season of the rainbow trout in this case, was from May to October, and as you can see, the October is actually the limiting factor here, and it's also the time when they have to get the fish out of the sea. So they have to do this harvesting and placement too, that is 0.3 meters. So it's quite challenging in many areas of the Baltic Sea. However, this approach is quite crude. It's not maybe a problem if the significant wave height goes over the threshold for a few hours, because the rest of the day you still can use. So then we started to look into this more detail, and calculated this event-based wave statistics. This is a similar approach that is used in the point measurements very often. You just give a threshold and look how often that is exceeded and for how long. And as you can see, from giving a different threshold, you get a very different point of view of the things and the number of the events. But for example, in the point of view of the fish feeder. It wouldn't matter if the waves went all the way to the 4 meters. If it was still over 1 meter for 13 days, they wouldn't go to the sea. So we calculated this kind of statistics for the area of the fish farm that they have in the Botnian Sea. And in the right figure, you see the number of the events during this growth season over this area. And in the orange triangle, you see the location where they have fish farm right now, or that is currently set to be okay location. And this blue is 20 kilometers offshore. That is area of interest that could be put fish farms also here. And then we calculated, looked into this situation more in detail, looked the number of the events in different locations, and as you can see, the number of events double if you go 20 kilometers offshore, and the percentage of time that's a significant wave height was over 1 meter in October changed from about 25% to closer to the 50%. We also looked at the distribution of the event lengths, so that people planning their structures would have this information of how long the events also last in general in the locations. In the inner location, 20% of the time events were higher than last longer than 27 hours, but then again in the outer region, those 20% of the time the events lasted over 36 hours, so 1.5 days, so that's a big difference in the system. We also calculated the same kind of statistics for the entire Baltic Sea, using at the warning levels. We have 4 significant wave heights for shipping. And in here you can also get the information about how long these events in general last. In the lower figure you see the median duration of exceedance of different thresholds, but you can also take the maximum or minimum percentile or whatever out of this information. So, to summarize, in FMI we have been developing wave models both in basin and coastal scale, and we have been trying to produce more and more useful, tailored products of statistics for our users at the sea. Development of a coupled ocean ice, wave ocean ice model has shown that inclusion of currents and sea surface heights has improved the forecast in some high wave or high current or sea level situations. And we are currently working on adding this sea wave parameters to the ocean models to possibly even more greatly improve the results in the area. Not necessarily straight away giving a better results, as the tuning is very much needed, as you saw. Our developments in the coastal modeling have made it so that nowadays we have improved our forecast nearshore so that people can actually use them close to the coast, even in the more archipelago-ish areas. And we have been giving more and more tailored statistics to maritime traffic and different offshore activities, so that they can not just think about the level of stress that structures can feel, but also take into account the maintenance procedures at the sea. So thank you for your attention.
Thanks a lot for also being so compact and concise. Questions?
One question about the fish farm and the development of Baltic. About the fish farm.
Yeah.
So, because I know in Norway they are making big offshore structures. They have to have high wave height than 1 meter. So can you decrease the wave height by engineering structures or somehow?
Repeat.
Lots of investments done in Norway, for example, in Finland.
Repeat the question for audience.
Not maybe a topic area, but anyway,
Yeah.
my question is that 1 meter is very low to me.
Yeah, so if we can increase the level of maintenance from 1 meter to higher, I think that's very possible by, for example, having different ships to do the maintenance. But often the fish farms don't have that kind of funding in Finland like they have in Norway. But that is very true that this very low threshold we might be able to increase them, especially if we can show that there's no places where these low values actually exist, or enough of those. They have a lot of money. Yeah.
Some more questions? Yes, please. Over there, yes.
Me?
Yeah.
Yes, thanks for a very interesting presentation. One of the first slides you showed the waves in front of the ice, sea ice, and some of them were getting very high. So how come that the ice controls that much of the wave height? Could you elaborate a little bit on that? Yes, that's...
Well, these very high waves, they have come from winds coming from the south. So in those regions we didn't have ice. And when we hit the very dense ice field, it dampens waves very quickly. And was that your question?
Yes, so how come that there are these really high waves in front of the sea ice? Is there some sort of dynamics between the waves and the ice particularly causing the waves?
Well, there definitely is. Our wave models work so that they simplify the situation a lot. So when we have ice information from the model or forecast, and where the amount of ice is high enough in the concentration, like over 30%, then we should say that there's no waves at all underneath the ice, even though in reality they do interact with each other, and it is a very important development step to the wave models.
So basically the problem is the specification of where the ice is. In this case, waves are coming from the south, and the high waves on the left picture, it's just because the model tells there is no ice in this region. So ice almost completely damps waves, but the question is where the ice is, which is not known in the model in time.
Thank you.
So how realistic can it be?
How realistic? These ice charts are information based on the satellite images, so they are quite realistic for that time, but they do not change in time. And the ice models themselves, they do tend to overestimate the ice, so it's not that realistic anymore, but it's work of development.
Just reminding the sentence of George Box, all models are wrong, but some are useful. Juha, please.
May I comment on this? I have been with Aranda in a situation exactly like that. And the entire Bothnian Sea, it's a very long catchment area, so you get very big waves in there. And also, just before the park, there's a deep area, so the waves can really form, and then as it shallows up, they get really high. And just like the reality against the model here shows that it eats at the ice edge quite effectively. And actually, when you're in the slush, the broken ice, you have huge waves going on many nautical miles into the ice. And we have been in there with Aranda doing ice measures, and it's actually quite scary. It's an awesome situation, you know, middle of the night, the ship's searchlights on, and you can see this ice field go ooh, like that, ship rolling about and everything. I think this is a very good illustration of the fact. Another thing, question concerning the fish farms. Have you considered the currents on the bottom in different conditions, since that is actually also very, very important, since it carries away the nutrient loading from the fish farms, and it's actually in a situation where you dampen the waves or do any construction in order to achieve that, you might actually end up in a situation where there's a kind of a stall on the bottom and everything accumulates.
Oh, good point. I think we definitely should look into that, but we haven't yet. Yeah.
Yes, please, and please wait for microphone. Or you have one?
I have
yes,
it
very
already.
good, thank you.
Thank you very much. It's a very interesting presentation. My question is, when you look at the coast of Gulf Finland, as you said, it's a very irregular coastline and it's very rugged. So how do you predict the waves behind or those islands or archipelagos, like really close? Do you need, for example, phase-resolved models in coupling with the larger model like WAM? Or like is there a strategy to go really close shore?
Well, one strategy that we have with the archipelago, with 1 nautical mile models, is that we use these obstruction fields. So we tell the estimates of how much these islands might dampen the waves and then weaken them, and we do that in both X and Y direction. But if we go to the more final scale models, then we don't have to use them always. Although we don't have resolution fine enough to resolve all of our islands anyway, so we always use those obstruction fields.
Right, yeah. Because kind of in contact with your colleague at the Norwegian Institute of Meteorology Institute, like Jan Victor and Konstantinos, we're thinking about like a downscale cascade modeling that's when you go really close to the coast and have irregular coastline, you can couple the WAM results to a phase-resolved model in a small scale for maybe even phase-resolved forecast. So that's also, I think it's kind of, can be the future, also good for safe navigation, kind of can collaborate over there. Just a comment there. Thank you very much.
Mm-hmm. Thank you.
Any more urgent or even worse, burning questions? I think a lot has been done, as Eddie was telling, but there is still a lot of opportunities and challenges. What can't be done in models, statistical models or WAMP-type models, even very high resolution, is a production of refraction in archipelagos. So the patterns of waves are no more simple wave crest. You will have a lot of pyramidal waves behind small islands and shoals, etc. And then you probably need experience from Norway to build phase-resolving models in critical places, just not to lose small boats who are going to hide themselves behind small islands, which is actually a very deadly exercise, I would say, to be in a crossing wave system behind a small island. So thank you once more for a very nice presentation and giving a clear picture where we are and also depicting some challenges what we have. Thanks.
Thank you very much.
And the first session today is like a mosaic, so we are now going to discussion of Estonian and Finland regional and cross-sectional cooperation in marine monitoring, and the title is so long that it will take a long time to read it, so I skip the second part of it, and it is presented by Mailis Laht from Estonian Environmental Research Center. You're welcome.
Yeah, thank you. Good morning. My name is Mailis, and okay, how is next? No. Back is not working, or okay, this is good. Okay, my name is Mailis Laht. I'm coming from Estonian Environmental Research Center. We are responsible for many state monitorings, and my field is more related to environmental chemistry and hazardous substances. This work that I will present today is about cooperation between Estonia and Finland, and also between the different fields, and as we have seen, this kind of cooperation really gives good knowledge change and also good results that we need for our decision making. So this presentation is prepared in cooperation with Estonian Geological Survey, Martin Liira and Sten Suuroja, and we have focused this time about this marine sediment analysis and how these two fields like geology and environmental chemistry can really have nice cooperation points. So as we know, the marine sediments are really a good matrix to look back in time, because they are in some areas really preserving the history. And as we know, we have really challenging things about persistent hazardous substances that we have actually used for many decades, but we haven't analyzed them in environmental conditions, and we actually don't know what the situations were before and how they are going. Are the trends really improving or not? So this kind of matrices really give us the possibility to look back in time. Of course, there are some limitations. You have to have nice accumulation areas, and you have to really be careful how you deal with those samples, that you don't have any cross-contamination and things like that. But still, if you have knowledge and if you are careful enough, then this is really useful matrix to analyze. So in that picture we have a nice example how this sample looks like if you cut it in half. This picture is taken on a cruise that we have had here in Gulf of Finland. So as I said, this kind of cooperation really, or this kind of analysis of this complex sediment matrix really needs information and knowledge from different fields. When we start from the sampling, then definitely information about the geological surveys is needed, because they know where the really good accumulation areas are for the sediments, how really sample those kind of sediments, and they have also this specific equipment that maybe is not so common for the regular monitoring in environmental matrices. So, but in the other hand, you have to know what kind of chemicals or substances you want to analyze and how they are behaving in an environment, so where to look them in the environment. When you put those two things together, then you have already really a nice starting point and you can take your sample. So next is important to know how long or how old those sediments are, or what kind of time they are representing when you're looking at this course. So dating is also something that geological surveys are focused on, and where they are really good, and where this kind of knowledge is coming. So where the samples are prepared and dating is done, then we can start analyze the hazardous substances, and this is already a kind of different, really complex field where you need different knowledge about chemicals. You have to have this equipment, also the quality control systems in place, that you really get the results that you're looking for. So here we have now combined those two fields nicely together and get some nice results that I will present a bit later. But before that, I jumped to this nice cooperation that we had with Finland, and the knowledge change about those two fields that we had this nice cruise on Aranda last year in October, where we discussed different possibilities for cooperation, and also took samples together using Finnish equipment and this long 6-meter piston corer that actually we in Estonia don't have. So this is really good that now our colleagues can analyze this kind of samples. Also, the samples were taken from Estonian waters, and also some other sampling was nicely done, and these samples are also now in further analysis. And I think this kind of cruise was really useful, as we had nice discussions, but still we had also the practical work, and you could see many things, and also discuss really like detailed points about samplings or other things that are related to this kind of work. So some pictures about this cruise. You can see here the sampling equipment, and also that you really need a big ship and cranes to sample this kind of cores, and afterwards the slicing and preparation of sample already on site is also important. So here are the nice colleagues that took part of this cruise on board of Aranda. So thank you all, and hopefully we will have this kind of events also in the future. So in Estonian national level, we also in couple of years now are trying to use this knowledge from those two fields, and here we will present the results where the samples were taken by the geological survey from two places. One is in Gulf of Finland and the other in Gulf of Riga, and then the analyses were performed during the Estonian regular state monitoring to get this long-time trends that we don't have for those substances. So first, from the results, I will show the trends in total nitrogen and organic carbon that really show that those samples were taken in a steady accumulation area. And we will move on to the heavy metals that are really analyzed maybe for a longer time, but still they are a nice background to see how they are behaving in an environment. So we can see that the sedimentation rates in those two areas are really different. So 1 centimeter in Gulf of Riga actually represents much longer time than in Gulf of Finland, but still you can see that the peaks, example for the cadmium, are really in the middle of 60s and 80s, so the time frame is quite the same, and now the levels of heavy metals are going down, so we have done something right, and our measures to protect the sea is actually working quite nicely. Here, two examples more about lead and copper. We can see that in some cases copper level is going a bit up, and it can be due that copper is now substituting the organotin compounds in these ship paintings to protect the ships from the
Anti-fouling paints.
Yes, anti-fouling, thank you. So, what about the organic compounds? As I said, the organotin compounds are really problematic in Baltic Sea and also in Gulf of Finland and other places, because they are really persistent and they have been used in really huge amounts, and hotspots or the point sources around the harbors and are really, really high. But when we look this Liivilaht or Gulf of Riga sample, we can see that actually more open areas, maybe the concentration are more steady. And those like upgoing trends can be due to that actually we have had some huge infrastructural construction going on in the area that samples were taken, or in the same area. So sometimes, and as we don't have so many comparison to see what are actually the reasons behind that, this is just a starting point, or we will see what other data will show us why those things are going up in some places. Also, those perfluorinated substances are really problematic in our area, and we can see from this Gulf of Riga graph that this PFOS itself is actually going down, because this is now been banned over 10 or 15 years. But other substances that are now substituting that are not having so nice downgoing trend. So this is maybe something to think about in the future about the decision makers. And to conclude, I think this kind of cooperation is really, really useful, and we should encourage that in the future. And as the marine geology does not know the borders, and also the waters don't know the borders, so we really need to think how maybe we can have this less white areas in Gulf of Finland that we have now in HELCOM assessments. When we joined our forces with Finland, then maybe we can do this kind of even like regular environmental monitoring, because this is now missing in Gulf of Finland. And as for many things, we don't have the capacity, and Finland maybe has, and maybe we have some other capacity that Finland doesn't have. So we really need to think about how to move forward with that. So thank you.
Thank you very much, Mailis. The point of your talk is like the point of Estonian foreign policy, never ever alone again. Any burning questions? Yes, please. Please use microphone for followers.
Yeah, so just to make sure, I understood that even the deep coring sediment, the piston core or gravity cores, they work well on Aranda, and you were satisfied with the work. Good, I'm happy to hear that.
And another question in the back, the middle row.
Yes. Are there plans to include radionuclides in the monitoring program, radon and radium?
Sorry?
Are there plans to include radionuclides in the monitoring program? I mean radium and radon.
Radionucleotide monitoringus, radionucleotide.
I think they are, but they are not in the sediments. Yeah, they are analyzed in the fish and in the seawater, but not in a sediment. But I don't know about that, so sorry.
It might be handy to have them as well. On the Finnish side, there has been quite some work done in the past.
Yeah.
And this is also a good point for the Finland collaboration, given the expertise in Finland.
Yes, thanks again. There is again a lot of opportunities and needs for the future. And now we go to another feature of mankind, which is called consumption. So you have to deliver goods for consumption. And again, a multi-author representation about sustainable flow of goods and decreased emission of transportation, presented by Cecil Gülmees.
I'm checking. Hello, everyone. My name is Cecil Gülmees. I'm participating from Estonian Maritime Academy. I am the very new postdoctoral researcher in very new and fresh research group, Maritime Transport Research Group. Today, I'm going to present our ongoing project, Sustainable Flow, which mainly aims at decreasing the CO2 emissions in Baltic Sea region. And these are our research group participants. We have 3 professors, 5 PhD students, and 1 industrial PhD, and 1 research assistant. Let's continue with our slides. So when we're talking about the emissions, you know that the actually refers to greenhouse gas emissions produced by the economic activities. So regarding the share of the transportation within all economic sectors, the transportation has the highest second share among the other economic sectors within 22%. And when we diving deeper into the transportation sector, and we can see that the maritime transportation has the one of the biggest contributor of the global greenhouse gas producing. So, as in maritime industry, international maritime organizations can be seen as the main regulator and set several standards for the shipping activities, especially for the vessels. They are also have several ambitious targets to achieve the zero emissions by the 2050 and try to get zero emissions by 2050, and they are setting several standards for the energy efficiency, navigation, safety, and the pollution at the sea. And one of those standards are Energy Efficiency Operational Index. And by implementing such kind of measures too in shipping industry, of course, we can see that we can catch a significant reduce, but it's not enough solely by applying such kind of measures. So we need additional measures to reduce the greenhouse gas emissions. Some of the IMO's measures covers the design, operational, and economic solutions, and some of them are, for example, design-related precautions or measures can be seen as the hull and superstructure and the energy management, and the operational and economic related solutions are voyage optimization, fleet management, logistics, and several speed optimization techniques can be used in the shipping industry, but of course we need an additional innovative and technological solutions to achieve that zero targets. So these are mostly related to the vessels, but of course, and many sectors, or especially the shipping sectors, can choose a path to green transition and follow their ambitions and follow their own measures to achieve that sustainability targets and the emission reduction targets. But regarding the IMO's regulations and the standards, where is the port? Where is the port placed their measures? So, and vessels' activities and the ship activities cannot be independently evaluated from the port operations. So it also requires shore-based activities. Like, of course, the ports industry also is a huge contributor to the greenhouse gas emission production. According to the United Nations, we can categorize the port-based emissions under three scopes. The first scope is the port direct emissions related to the port-owned fleet vehicles, buildings, and the stationary sources. And this scope 2 is the purchased electricity. Of course, ports are using the energy, and this energy maybe comes from the fossil fuels and the other resources. So they, while producing that energy, it also produces the CO2. And the scope 3 is the port tenant-related activities also contributes the CO2 emission production in the port area. So within the light of all those information, our project Sustainable Flow, which is funded by the European Union and prepared within the context of Interreg Baltic Sea program, we mainly aim to develop practical solutions and digital tools to support CO2 reduction and energy-saving measures in transportation. And these attempts try to create an energy-saving and production of the renewable energy at ports. So, who we are actually? We are 4 country and 7 pilot ports. We are collaborating with that ports for collecting the data, surveying, and the implementation of the project, actually. Our pilot ports are Port of Roma, Port of Pori, Norrköping, Öksund, Mariehamn, Tallinn, and Port of Riga. And our project partners are the Satakunta University of Applied Sciences as a lead partner, and the Swedish Maritime Administration, Åland University of Applied Science, International Transport Development Association, Tallinn Technical University, we are, Fintraffic, and Swedish Confederation of Transport Enterprises. So what we are doing actually in this project, we are just at the beginning of the project. So first of all, we try to determine the current situation of the ports and their tendencies to address the European Union and the United Nations goals, actually. So we are analyzing, collecting the data and surveying the benchmarking of the current operations, and we are trying to actually catch the gap, how we can implement the energy efficiency measures and how we can create additional energy efficiency measures. So this is also from our site visits with our partners and the pilot ports. And thank you.
Thank you very much. A clearly necessary thing to do in order to reach the future which is worth of living in. But I think that there will be many questions from audience about how it is practically possible to do. Juha, please.
Thank you for a very, very nice presentation. How would you rate the fact that the future fuel for ships in, let's say, foreseeable future is shrouded in the great, great uncertainty? How do you rate the significance of that?
Actually, it requires, the technological advancement. Actually, IMO has, of course, set several measures, and the first one is they are focusing on mostly operational and the design aspects, and for the fuels and future fuels, they are still, making so much investment to find a new solution, especially for not finding a new fuel solutions, but also distributing them across the different regions. So actually, this is I think the most urgent issue, designing the supply chain of how we can distribute that fuels, actually.
Very good answer. We just had the International Research Ship Operators meeting a couple of weeks back in Belgium, and there we had a legal view and the IMO's view on the future ship propellant fuels. And the fact is that it's absolutely uncertain yet.
Yeah.
Depending on the production and the developing economy and the distribution, like you said, it's shrouded in great mystery yet.
Yeah.
Thank you.
Yeah. That's why they are postponing the targets, 2050.
Some more questions? I think this uncertainty in the future is just one part of the structure of the universe. We can't know everything about future. This is forbidden by, for example, by the laws of nature, so even Newton's laws. I still have a nasty question. One of your diagrams was telling that up to 75% of reduction is possible by optimization of ship speed. Optimization of ship speed means that the consumer must wait. If the consumer becomes nervous, what are the consequences and who is going to pay for that?
Actually, this is a good question, and this is our very new research question with the Professor Tapaninen. And actually, it should be argued that we all say that the sustainability is good things for our future, but how the shippers are available or aware of this concern. So this is the first thing. I think the continuous and ongoing pressures may be one-sided, according to me. Of course, it needs to be increased the consumer awareness about the green feature and the sustainability, I think.
Thank you, and it's again, never, ever alone again. We have to do that together. Thank you very much. Now we are to some extent reverting to the topic which was addressed by Mailis. It's about common and transnational use of research infrastructure for every purpose, basically, and the presentation will be given by Juha Flinkman from Finnish Environment Institute. Please.
Okay. First of all, I would like to thank you very much for inviting me here, for giving me this opportunity to talk about the research vessel and their transnational use. This is something that has been required from us by the EU for already decades, and I'll be coming back to that. In the opening slide, I have two large research infrastructures. The other one on your left-hand side is Aranda, and it's an existing thing working towards the end of her life, and the one on the right side is just a concept image of a type of multipurpose vessel, which I believe right now is under the procurement tender for the Estonia. And it's just an idea. It's not the image, so to say, but just to give you an idea. And we work the same area, so this is what I'm going to be talking about. But first of all, I have to put out the disclaimer. What I'm going to be talking about now is not an official suggestion by Syke or any other Finnish authority. It's my personal opinion, based on my plus 20, 30, 40 years of experience as a research vessel user, as a scientist, a chief scientist, research vessel operator, and a developer. And the key word here is the TNA, the transnational access. Like I said, this is something that has been required from us for a long time already. And all the research vessel operations within EU and also the rest of the world are aiming towards this. And in the core of my suggestion is the basic idea of the most cost-efficient use of these large research infrastructures in order to achieve the transnational goals in marine environmental monitoring and science. Like Mailis very well pointed out, that the seas know no boundaries. Either if it's pelagic science or marine geology, anything, there's no borders there. Now, I will probably get a bollocking out of this, but at least I think it needs to be said out loud. Here we go. Okay, the experiences of research infrastructure sharing we already have between Finland and Sweden. The Swedes lost their research vessel, the old Argos. Somebody found out that actually the insulation material was asbestos, and the ship was scrapped before the cat had time to fart. And then they were without the ship, and they tried first their coast guard cutters, and they didn't like it. Then they operated on Aranda from 2014 to 2019. And that operation, of course, everybody knew from the onset that it's temporary, as the Swedes were already procuring their new vessel, which they eventually got, and it's a nice fine vessel, the Svea. But the thing is that this cooperation was very successful, and it was not only about the increased sailing days and a replacement vessel for the Swedes and for sailing days for us, but it also resulted in removal of a lot of overlapping work, which we had done previously. Many cruises where I was a chief scientist, I was actually, we were working on Aranda on some research station, and the Argos was waiting to do the same thing after us. So a lot of this we could avoid. The Swedes are now taking care of the monitoring of the Baltic proper and the western coast, and we do the Bothnian Bay system in the winter, as their new ship is not the ice-going vessel. So the advantages of removing the overlapping work and organizing the monitoring in cost-efficient way, that actually remained after the Swedes no longer needed our vessel. Well, what about us then, Finland and Estonia? We are actually monitoring the same water, the same thing as between us and Swedes, but even to a further extent. Nobody else is monitoring the Gulf of Finland. So these are thank you, Urmas, for providing the data. These are the Estonian offshore monitoring stations. And then when you put our offshore monitoring stations and make the image a bit transparent, same stations, same water for the most. So if we're thinking about that, so we might as well be pulling on the same rope. We're monitoring the same waters, same stations, doing the same thing. So what I'm suggesting here is that we should seriously think about harmonization, our monitoring programs. Not that you would charter our vessel or we would charter yours, but we just totally harmonize them and start working together. The idea is that, of course, this harmonization, it would be a lot of work. Estonia has 6 cruises annually, we do 4. The station networks, many stations are the same, but then again, there are many stations that are different. And of course, you cannot break existing time series. Those are the most valuable assets of any monitoring program. But it can be done. These things can be combined. You just need a careful evaluation and planning. And this is what we did with the Swedes, and it works just fine. Monitoring, of course, is under quality assurance systems and the certifications, and we each have our own. But we have had intercalibrations, and we're not that far off from each other, as far as I understand. So basically, it's a doable thing. It is lots of work, but there are also advantages. For instance, Aranda today, she's capable of working all year round in any parts of the Baltic. She works 24/7, which actually, at the end of the day, saves a lot of money in man hours and cost of ship time at sea, which is the highest thing here, the most important. And the advantages in this would be that we would have more sailing days for Aranda, and Estonia, you could access this infrastructure when we actually harmonize the monitoring by just covering the cost of your own use. You wouldn't have to charter the vessel. You just cover your own cost. We would do the combining the monitoring cruises together. Combine our science crews, do the work, do all the stations, and then just calculate which proportion is of the cost is on which country's responsibility. And also, what I suggest we should definitely do on these monitoring costs, which we have been doing for many years, since all the time Syke has had the responsibility over Aranda, there actually haven't been any real marine science cruises supported by Syke, even though it says so in the law. So we have always combined scientific research programs with the monitoring cruises, whenever they fit the cruise program. Whenever there's free berths on the ship, welcome. And this we could do together. So we could also, in addition to monitoring, advance the production of good marine science. And after all, we have to understand that if we just stick to monitoring, it will not develop anywhere. And at the end of the day, in even foreseeable future, we might be monitoring something that we wouldn't have wanted to do in the first place. We need science to develop the monitoring, open the black boxes, understand the ecosystem workings, whatever it is. So at the end of the day, avoiding overlapping work would mean more resources for the monitoring, development of the monitoring, and doing good marine science. Well, what about the coastal monitoring then? We have used the ship of opportunity for this, and we actually have a very well working container system. It's based on 2 20-foot containers, sampling lab and an analysis lab with the piggyback A-frame and winch system on top. And it has been successfully used on different kinds of ships. Actually, the lower image is the Finnish flatbed supply vessel, which was used by the Swedes when Aranda was docked for the repairs. So actually, your new vessel, if the procurement becomes a reality, it's a multi-purpose vessel, and due to the restrictions of the Estonian waterways, it has to have a shallow draft. So actually, your vessel, the new vessel, then could be used also for Finnish coastal monitoring, and you could use our container system. It's a good system, but they're not cheap. But once you get them, they work. So eventually, we could have a Gulf of Finland barter market for ship time. Trade ship time, because the ships will be different, and they have different capabilities. So. And I already mentioned a couple of times this drive from EU and the international research vessel operators that the transnational access to large research infrastructures like the research vessels, it's really a strong drive. There have been projects like the Eurofleets. Urmas, Estonia has been with Eurofleets already from the beginning. We got on board as fast as it became my time to work it out. So Eurofleets was a EU-funded program to facilitate access of scientists who would naturally not have access to research vessels. They would supply or apply for funding for a cruise, and then it would be evaluated, and if it was successful, then they were granted the research vessel for their purpose in an area where they wanted to work, and then the expenses of the research vessel usage was paid for the owner. Aranda was used in the last program. Taavi Liblik was the cruise leader, and it was they worked together with the Finnish Meteorological Institute, and it was a very successful cruise. And the development and the goal of the Eurofleet system has been always that it will have to become a permanent financing issue, permanent funding body for research vessel use. And this is now what we're trying to achieve and put together is the Eurofleet's RI, research infrastructure. This is the goal. The steps forward would include that we should utilize the available resources for working the same water. And that is actually, in my opinion, the most cost-effective way of doing this. It's kind of funny, these days, that our nations are richer than ever before, and we can't afford bloody anything. It's always the cost. No, it costs so much. The cost efficiency, we need to be able to show the decision makers that we are doing this as cost efficiently as possible. So what should Finland and Estonia do is do all these things that I've suggested, and also join the Eurofleet's RI, become part of that, because that funding instrument would provide us a possibility to do a lot of good marine science. Eurofleet is not for monitoring, it's for marine science, but these two things are not separate, they are intermingled. So I really recommend the participation to Eurofleet's RI, and because that will really increase the possibility to really do free marine science with research vessels. And to conclude, in the coming years, these two ladies need to be replaced. I don't know, Salme is probably closer to the end of her lifespan. Aranda has to be replaced sometime during the 2030s as she reaches the end of her lifespan. And the new vessel in Finland has already been mentioned. So it's not official yet, but it's already been mentioned at the Sykyen ministries, and that means that the planning may or is about to start, but that is a long process. It takes 10 years minimum before we have a ship. And also, like we just heard in the previous presentation, and we discussed the fact that what fuel the ships will use in future is a big question mark. That we live in times where the challenges are totally new, and they are, like I said, they are shrouded in mystery. The good thing with Aranda is that the lifespan of Aranda is ready to use biodiesel, all biofuels, and she's good for that already, and we have used those fuels operationally, and that will solve the problems for Aranda, but not for the new ship. What is the propulsion power for the new ship? We have no idea yet. Nobody has. State of California wants a new research ship for their Scripps Ocean Institute. They are actually opting for a totally hydrogen-driven ship. It will cost over $100 million, but the state of California is good for $45 million because they want it. The state of California is going for the hydrogen economy because they got lots of solar power, wind power to produce it. What we will do, well, it's up to the future generations. So with these words, I'm just saying thank you very much, and I would be happy to take any questions, any suggestions, or any bollocking. I'm good for that. Thank you.
Thanks a lot. You will take any questions.
Okay.
Yes, on the end there, please. But wait for the microphone.
Thank you for that. And I talk from bitter experience from a previous life in Australia, but often getting the infrastructure as a one-off thing is the easy part. Keeping it running is the difficult part. And the more expensive and large and capable these things are, the quicker the smaller institutions sort of get priced out of the market. And then even with the big institutions, like your own, it only takes one political decision to reduce the sea time, and it seems often to be an easy source of money for government to cut those sort of expenditures. And then you get into a downward spiral where the vessel isn't at sea very often and therefore is no longer required. I've seen that sort of cycle happen a couple of times in my career. I absolutely compliment your comments on trying to obtain permanent funding, but I just wonder, is that a realistic thing to do, which is obviously the requirement that we need to have to make these things work?
Well, actually, since the discontinuation of Finnish Institute of Marine Research in 2008, which was one of the most brilliant decisions by Finnish government and parliament, this is sarcasm, we have been in that spiral. And my career as the manager for Aranda, and the same thing with Riitta, my boss, and everybody else, has been a constant mud wrestle uphill to maintain the ship and at least maintain the minimum of sailing days. We're talking about 100 to 150 sailing days these days, and it's way too little. But why I'm here today and talking about this, there's two things. First of all, there's the Eurofleets program that is advancing pretty well, in my opinion, and nationally there is something happening right now which is changing things, and the attitude towards Aranda and research vessels in general is changing. There has been a lot of people with very slick moves and good ability to lobby things, and these people mostly talk about the automated system and remote sensing and all that, and they are claiming that, yeah, these replace the research vessels. And that is the biggest line of extreme nutrient loading, if you like, the phasing. Anyway, even a lot of decision makers these days, they are beginning to understand that you can't work without the research vessels. Who's going to service all your automated systems? Where do you get the ground proofing data? Where do you get the in-depth data of the ocean? So this is I totally share your view, and I know what you're talking about, but there seems to be a bit of a carpe diem moment right now, and this is what I'm trying to utilize here. I hope this answered your question.
Yes, Urmas, please.
Yes, thank you. Thank you, Juha. It was a very nice presentation, and I think it's a very, very long process. I remember then it was in 2007 when European Marine Board published this position paper about the research fleets in Europe. Now it's 16 years. And we are still there. We don't have it. But we have had 3 Eurofleets projects, and we have been talking with many of scientists and also administration that this has to be done in that way that you just presented. But for Estonia, it will be a very big change, because in Estonia, we don't have a governmentally supported research vessel, because I'm managing research vessel which is not supported at all by the government. We are just participating in some procurement processes. And for the thing is that to keep this vessel, we do quite a lot of work for enterprises. This year we have more money coming from enterprises than from the government, and then also we do the monitoring for Latvian waters. It means that there are quite a lot of work around, but we have to cooperate with Finland, Estonia, Latvia, because Aranda, if our government will afford that this will do the winter monitoring, for example, this would be the best decision ever, because what we miss sometime when we have ice, for example, then we miss the data from coastal areas. It has to be done somehow and decided somehow. And then when there will be another vessel or whatever vessels, we have to have this market or something. But again, for Estonia, it will be a very big change because it has a line in the budget has to appear because it's not there at all. But I'm optimistic, but let's see.
Yeah, I know it's none of us who have been in this business for any length of time are not overtly exposed to super duper optimism, but well, close to the end of my working career, now I see things happening that really make a big change. So this is, in a way, like I said, a carpe diem moment, and we should go for it. And like I said, that was a good point, Urmas. I'm not suggesting that if this becomes a reality, you do everything with Aranda. The winter monitoring, for instance, is the key thing. That's one capacity that Aranda has. And then, if you get the new vessel, there's a lot of work both in science and also in business, like the wind farm stuff. Aranda is already being asked for that all the time, and therefore we are in the process of sort of reforming the basis on how we define the cost, so that we don't disturb the market, but still get. We need to get like business for the ship as well. Okay, thanks.
Thanks a lot to all speakers and questions. And I think that good ideas are much easier to digest together with coffee in the coming 28 minutes. Thank you. Yes,
Yes. Okay, let's start slowly. So welcome from my side as well. I'm Pentti Kujala. I have done a lot of research in Finland in Aalto University, but now only 1 day a week in Aalto, but full-time, more or less full-time in Estonia Maritime Academy as a full professor. So very happy to be here, and my aim is to start making a new research group on marine traffic safety. That's my aim, and I'm very happy that I can work in Estonia and in Tallinn. Okay, and then I will chair this session, and we have 4 papers in 1 hour. It gives us 50 minutes per paper, and then hopefully there's some time for discussion. So if possible, try to do it in 10 to 30 minutes. I try to keep the schedule. And we start by Loretta Kelpsaite-Remkine, and she will talk about sustainable coastal management strategies for South Baltic Sea based and network-based analysis of key factors and solutions. I like the Bayesian because Bayesian is also very fond of my modeling. Good. Okay, please.
So hello, and now let's move from the Gulf of Finland to the central part of the Baltic Sea. And I want to talk a little bit more about that short stretch of the coast between the water and the cities, which in our part, in the Lithuania, we have nice sandy coasts. And Baltic Sea coasts actually are vulnerable in different terms. It's very, very intensely used coastal zone in different terms, or in the recreational, or in the economical, the different economical activities. And in different planning documents, on different levels, starting from the European Union level, national or regional, we have different understanding and different terms how to develop this coastal area. And our aim of our study was to find, let's say, how to separate the different point of view of what politicians have, how the coastal zone should be developed, how the local citizens see the future development of their coast and living areas, and how to combine the different point of view and to live in the happy, sustainable world. And even for the people, the recreational purpose of the coast, which is all our Lithuania 90 kilometers, dedicated to the recreational purposes, may have different way of the recreational stuff. Or we have that nice left picture, that one of the recreational activities, just simply lying on the shore, or on the right corner we have different recreational activity. That's national Lithuanian sport, means amber fishing. And we should have the totally different physical and environmental conditions to have that different recreational activities at the same spot of the coast. And as the study area, we took very narrow part of the coast. It's actually Klaipėda city municipality. The beaches which belongs to the Klaipėda city municipalities. We have at Klaipėda 7 official beaches, which are separated by the port of Klaipėda, one of the largest harbors in the Baltic Sea. And port of Klaipėda actually separates Klaipėda beaches into the 2 different parts. One is on the Curonian Spit, if you may see, though it's Smiltynė 1 and Smiltynė 2, and others are on the mainland. It's Melnaragė and Giruliai beaches. What is the main difference? southern from the port of Klaipėda, you may see nice wide beach with the accumulation signs and warm water, a very shallow bottom slope, so perfect for the families with their little children. And northern, we have little different and geological and morphological type of the coast, as it suffered from the coastal erosion directly to the north from the entrance to the port of Klaipėda. So first picture, Melnragė 1, but it's perfect spot for the active different water sport. And Melnragė 2, second beach, is with less signs of the erosion, but sometimes you may have the water from the Curonian lagoon, so not nice view of the water, so a lot of algae. And handicap coast, it's already close to the biosphere reservoir, to the national park, with a nice view, but very narrow sandy stretch between forest and the shore, and already not so nice sand, but with some pebbles and stones. What methods we use to separate the physical factors, the information what is put into the documents, and what people are thinking about their use of the beach. So we made a survey of the more than 100 Klaipėda citizens, where we asked their opinion about what is the key factors for them to choose the beach where they're going in different seasons, and we put all that data together with the physical parameters into the black box with the name of Bayesian network. And there were 3 major steps. First was quantifying current beliefs via prior distribution, quantifying information provided by new data via likelihood information, and with using Bayesian theorem, update beliefs and form distribution, what was real thoughts behind the beliefs of the people. Schematically, the method looked in black box we named sustainability, and what the data we put it into that black box. From the documents, blue flag sites and UNESCO World Heritage, as Curonian spit, all the Curonian spit belongs to the UNESCO World Heritage. And biosphere reservoirs, which is a part of the northern part belongs, and different economical dimensions. That was one of social economical factors. Physical and ecological dimension was what dominant seaside features we have, data on air, water, temperature, waves, and in the questionnaire we asked people what are their opinion about the importance of these parameters. And social dimension was information what we got from the planning documents, different management documents, development plans, of how the protected areas are described, and numbers of monthly mention of different beaches in the surveys, and some other data. So results actually looked in that way. As close, this small circles are together, the closer relations are. And actually for us was mostly surprising. Result was that air temperature and wind direction were shown as the greater importance to relation to other physical and geographical factors to the citizens. And the second very interesting finding what we saw that actually blue flag award are not interesting for the citizens. That's more important for the politician stuff, but for the locals people, they don't care if their beach have the blue flag or not. So that's one of the example of the chart what we got, but there were several of them, and to combine, so summary of the results, we can describe it in that way, that air temperature and wind direction were shown to be greater importance in the relation to other physical and geographical factors, as the conditional probability with higher compared to other variables. And what beach people are choosing for their recreational purposes, actually the distance to the beach and how easy to reach it was more important than quality of the beach. So Smeltina beach, even if they are more nice and with more infrastructure for the recreational purposes, they are harder to reach. So mainland beaches are more popular between Klaipėda citizens. And in the off-season, the beaches which suffer from the coastal erosion were more favorable for the locals. We have higher waves and nice view to walk on those beaches. And existence of the Blue Flag Awards has a significant predictor for the development plans. We afraid to write that, guys, we are not interested in the blue flag, so it's a nice political way how to say that. And the presence of sandy beach and dunes were shown to be highest influence prediction. And you will never guess why the dunes are important, existence of the high dunes are important in our part of the Baltic Sea. That's a perfect place where to hide when, or to have the sand bath when we have a strong wind. So it's sheltered from, and there are always warm and nice place. In the conclusion, so the Bayesian approach provides valuable tool to have a wide range of application and different level of difficulty when you need to combine and to find a relationship between the data which can be measured by numbers and the data which are human opinion, which cannot be measured by numbers. And physical geographical affected by factors of others, two pillars, the sustainability, economy, and society, than by the system itself. And location and the beach type actually are more important for the people than bathing temperature at our part of the Baltic Sea. And significant of the sandy beach and dunes are widely reflected, not only in the planning so reflected in the all planning documents at the regional level. So politicians already know that we should somehow preserve our sandy beach, but they are still fighting how to do that. Thank you.
Very interesting study about how to combine different topics. Any questions to Loretta? So I can support your idea about this Bayesian modeling, because you can make very advanced statistics, but you can also make human opinions and combine different opinions, because in that kind of topic when you are studying, you cannot make statistics, everything. Yeah.
So we can see, so we saw that people prefer to go to the not nice coastal erosive beaches on the mainland, but we hardly could to prove why they're doing that. And we were happy that from the survey, together later with that, so that Bayesian networks combine that documents, information from the political documents and human surveys, people surveys, and they showed us that actually they more like actually wind direction, because and even not velocity are not so important, because locals know that when we will have southwesterly wind, even so for the second or third day, we will have high waves, but nice weather to walk next to the sea. And that's what we knew from the beliefs. Now we have proved, so we may show to the decision makers that let's see the numbers.
Good, and I agree. This layer is very good to visualize, even that you can visualize, even politicians can understand. So yes. That's important. Okay, we are just on time. Thank you, Loretta, once more. And next speaker is online, as far as we know, and it's coming from FMI. And it's a very good topic, breaking down the silos. Transboundary and intersectional cooperation must be strengthened. I like the title, so let's see what Anna-Stina will say. Anna-Stina Heiskanen, you are online, I hope. Can you hear us?
Yes, I can hear you very well. Can you hear me?
The floor is yours. The line is yours. Online is yours.
Okay.
Good,
yes,
we can see you. I hear you. Very good.
Okay, thank you very much for the opportunity to make the presentation in the Gulf of Finland Science Days. And I apologize that I'm not able to be there in person due to the various obligations on my day-to-day work at the Finnish Environment Institute, where I'm leading a unit of marine and freshwater solutions and other issues that I couldn't join you this time, but hopefully next time it would be possible. Nevertheless, I suggested this presentation in order to inform the audience that and the scientific research community that is attending these Science Days of the Gulf of Finland, since for a very long time I've been able to follow also that what's going on in the Gulf of Finland joint research activities. Since then, I have been joining the UN Water Convention for Transboundary Rivers and Lakes, which is a global water convention. And together with my colleague, Mr. Harry Leave, who is a special envoy of transboundary waters and working at the Ministry of Climate of Estonia. And for the last 2 years, he has been the chair of the Bureau of the UN Water Convention, as Estonia is chairing this water convention under the UNEC and UN, and the secretariat is located in Geneva. So we thought that it would be interesting for you to hear about some activities under the UN Water Convention dealing with source to sea management, which I think links very closely to the issue and research activities needed for the management of the Gulf of Finland and, of course, in general, the Baltic Sea and Eastern Baltic Sea as well. So let's go to the next slide. So first of all, I just tell you the main message of this information presentation. I think that many of the scientists or researchers working on the Baltic Sea can agree on this, that the pollution flows must be tackled at the source in the catchment area before those enter the freshwater or the marine environment. That's the very efficient place to deal with the pollution sources. And then transboundary river basin organizations, as there are many catchment areas, rivers and lakes that are transboundary around the globe and around the Baltic Sea as well. The marine conventions and the UN conventions, they should and they can cooperate for joint actions and policy development, which is very important really to have this effective management of pollution sources that are flowing from catchment areas to the coastal marine areas. And globally, actually, such actions require building novel collaboration initiatives and breaking down the traditional freshwater and marine silos of national, regional, and global organizations. And often it also applies to research and scientific communities as well. So there could be something fruitful, low-hanging fruits that also help both of the communities in freshwater catchment management as well as the coastal marine management. So the background and motivation to promote source-to-sea management is actually that more than 60% of freshwater resources worldwide are shared by 2 or more countries. So transboundary waters are actually one of the major carriers of pollution in the marine environments. And thus, the source-to-sea approach is something that aims managing land, freshwater, coastal, and marine resources holistically and bridging the existing gaps to tackle marine pollution at the source upstream, namely. I mentioned already that Estonia is chairing currently the Convention on the Protection and Use of Transboundary Watercourses and International Lakes, which is called the Water Convention. And this convention aims to help also to build bridges between the sectors, countries, and balance different interests and involve also multiple stakeholders and institutions to provide policy advice where needed. And this also is linking to the current ongoing reporting that the UN or countries globally are carrying out, namely the Sustainable Development Goals. So the SDG 6, more closely 6.3, which deals with wastewater and water quality, is very closely linked to the purposes or linked to the means and measures how to protect the coastal marine areas, as well as the SDG 6.5 about the integrated water resources management in the catchment areas. And how that is done impacts also the achievement of the Sustainable Development Goals 14.1, which is aiming to demonstrate the reduction of the marine pollution worldwide. Why transboundary cooperation would be relevant for the source-to-sea management? So, as I already told, majority of the world basins, and here you see the map of the world basins that are transboundary. For instance, 6 out of the 10 rivers, they contribute 90% of the plastic waste to oceans and are transboundary. So actually, in order to tackle the very severe marine plastic pollution, there needs to be cooperation and joint bodies across the countries that share the same water flow resources. And transboundary cooperation can help to use resources and allocate the costs for the protection and pollution prevention more efficiently and hopefully eventually also to reduce those. If we look at the Baltic Sea, and a few years ago there was a document report about the 7 biggest rivers in the Baltic Sea region compiled by HELCOM experts. And there we can see that really the Eastern Baltic, the big rivers, 7 biggest rivers that are contributing more than 40% of the phosphorus load and more than 30% of the nitrogen flow to the Baltic Sea are actually transboundary across the eastern Baltic countries. There's also Göta and Kemi River, but they are really contributing major part of the nutrient flows to the Baltic Sea, which is the major problem, the eutrophication in our region. So just to tell you briefly that the Water Convention is actually starting the activities in relation to the source to the sea management. And they organized a workshop, which was already last year, which was led by Estonia, Harry, my colleague, and the Slovenian vice chair. So the aims was to increase the understanding and interlinkages about these really interlinked systems and really showcase the available best practices and practical steps to promote the effective sea management and discuss the challenges and possible future work areas within the Water Convention next work program and beyond. And also to remind that to take this topic that is actually very high in the agenda of the Global Water Convention. For instance, already a year ago in UN Environment Assembly, Ocean Conference 2022, and this year there was a UN Global Water Conference, which was actually historical because the previous one was 47 years ago on the UN level. And there also the issue of the linking the source to sea approaches was high in the agenda. There's a link if you want to know more about the outcomes of this workshop. There were several organizers for this, for instance, a UN Environment Program and the Global Water Partnership and the Stockholm International Water Institute as well, and others. This workshop came up with the outcomes which are in a way framing the future activities, hopefully, in the Water Convention as a whole. So it was stated that the holistic approach is necessary because there are institutional and legislative silos and better coordinate across sectors and national borders. For instance, the legislation number of different frameworks and legislation that are governing both the catchment areas and coastal marine areas is very wide, and actually there is different silos that might be even counteracted. There's also stronger coordination between decision makers and researchers will be needed. And even if Water Convention sort of historical, traditionally since 92 when it was established, it's also called Helsinki Convention because it was established in 1992, actually in Helsinki. It has also the protection of marine environment among its objectives, although it deals with the transboundary waters, mostly in rivers and lakes, but also, of course, estuaries and transitional waters are shared by different countries. And because this aims also to prevent and control and reduce the transboundary impact as well. It was also found that there needs to be a better cooperation between river basin organizations, that there are several, and also the Marine Convention or similar organization by setting the objectives and implementation and action plans for the reduction of the pollution. Good example, I would say, it's really our HELCOM that is already acting very much in collaboration with the river basin organization. And of course, in Europe, we have the Danube River Commission or the International Commission for the Protection of the Danube River, and the Black Sea Convention that are working together despite a huge number of different countries. I think there are 19 partners in the Danube River Commission. Then the next one, time is running. Also, of course, the data information exchange, harmonization of surveys or monitoring, standardization of the monitoring could be part of the cooperation between River Basin Organization and Regional Seas Convention. And HELCOM is very much working on this, on the marine monitoring and marine assessment systems. Mapping the pollution pathways from source to sea is really needed to improve the understanding of the common goals and also to support the prioritization of measures and actions both on the regional and global scale. What is also crucial would be to highlight the benefits of the source to sea management to the upstream countries that might be even landlocked or are not sharing coastal areas. For instance, the benefits of an ecosystem protection on coastal areas or restoration, what benefits they would transfer upstreams. For migratory fish, of course, are quite obvious in that sense, but there can be also others. And synergies would be needed better by integrated water resources management and international integrated coastal zone management and marine spatial planning. And that is something we also work in the Baltic Sea scale. Draft outcomes, awareness and capacity building is also very crucial. So the research community, I think, plays a very important role both in the marine and freshwater communities and linking the knowledge of the different flows of large-scale transboundary river system to the large marine systems and impact on the inland, on the coastal seas, but of course at ocean as a whole. And to understand and identify the clear management objective for those. We also need to demonstrate the economic and social benefits. And capacity building is very important there. Thus, one of the possible future work program under the Water Convention would include then cooperation also between the action platform for the source to the sea to develop tools and build capacity there. And finally, I think that in HELCOM, in the Baltic Sea, around the Baltic Sea, HELCOM is working along these lines and provides a very good example also for the Water Convention with respect of the transboundary waters management and how to link those to the coastal waters. For instance, Baltic Sea action plans that has 36 actions on nutrient loading and also to tackle hazardous substances. There's a specific Baltic Sea regional nutrient recycling strategy where the actions are on the agriculture particularly, and finally 13 actions to reduce marine litter, which also includes microplastics. So what I would like to convene to the audience there, although I'm not there, is that the transboundary convention or commissions that we are working have also an important and a necessary role for the protect and provide these interlinkages with the coastal and marine research community in order to promote the source to the sea approach. Thank you very much for your attendance. And there is some information of the web as well. Thank you.
Yes. Okay. Yeah. Thank you, Anna-Stina. We are a little bit behind the schedule, but any urgent questions? Maybe one comment I can have that I totally understand that the rivers are very important. Actually, we have been studying a lot about the sea and lakes, but maybe the sea, but the rivers maybe not too much. So I'm very happy to hear that this kind of a cooperation is ongoing. But I can imagine this international cooperation, how to fund it, that can be one challenge. Typically, whenever we want to cooperate internationally, the funding is always a problem. But can you comment about the funding possibilities? Any comments?
You mean the research funding?
Yeah, research funding,
possibilities?
yes, exactly.
Yeah, for instance, there is an Horizon Europe partnership, Water for All, that is ongoing at the moment and started to work in the beginning of, and that this is a partnership program that is also opening calls for interlinkages between the coastal or inland and freshwater and coastal communities. Currently, there's a call on ecosystem services, but it also includes a pillar that deals with the international activities. So that could be something to explore also for the community in the Baltic Sea. And I think that the Baltic Sea community has a lot to offer in the capacity and also the knowledge on the research activities that are needed to promote the source-to-sea approach globally. There's a need for that.
Okay, thank you. So, any more questions, or we go forward? So, thank you, Anna-Stina, again, and we continue here. Thank you.
Thank you.
And next speaker is coming from here. It's Maris Elsalu from Tallinn University of Technology, and now we go to transport, but not marine transport, we go to sediment transport and quantification of longshore sediment transport and compartments in urban areas. A case study of shores at Tallinn, Baltic Sea. Well, yeah, please.
Good afternoon. Dear organizers, dear audience, thank you for this opportunity. I will switch now to coastal areas and particularly to sediment processes on the coast. And I will present some of the newest results on quantification of longshore sediment transport and compartments in the urban areas. And case study is about shores of Tallinn and the area's vicinity. Anthropogenic structures, as we all know, exert diverse effects on coastal environments and often disrupting or altering the nearshore natural seascapes. And the impact of these interventions on coastal systems reaches to dramatic level when a source or a major pathway of sediment is affected. This work lies on the possibilities to systematically identify single littoral drift cells in sedimentary compartments in the urbanized areas with complicated geometry. And this approach serves an important tool in engineering and coastal management decisions for sustainable coastal planning and hopefully preventing some bad planning and decisions in coastal areas. The study area is the near shore of Tallinn Bay. It's located on the southern coast of the Gulf of Finland, Baltic Sea. This region hosts a specific bidirectional wind and wave climate. Prevailing waves are from west, but the most severe storms in the year often tend to occur from northwest directions. And the area or the coastline in the study area, the orientation of that varies considerably. That makes the things more difficult. To identify these main sediment compartments, we have employed widely used CERC method to estimate wave-driven longshore sediment transport. And here we have utilized the common wave parameters such as significant wave height, period, and wave direction. And now to estimate this sediment transport, longshore sediment transport driven by waves, we have utilized 3 different wave statistics derived from 3 different wind datasets. These datasets were applied to the grids with varying spatial resolution and also different model configurations. The one model with resolution 470 meters was run for the 1-point marine winds measured in Kalbada-Grunda, and the other wind datasets, ERA5 and Baltic 65, were used for the higher resolution grid, and the SWAN model was used. These wave datasets were calculated by other colleagues. And these theoretical estimations of the potential sediment transport were partially and qualitatively validated against detailed surveys on the changes on dry beach on the major accumulation areas in Rusalka and Pirita Beach. Detailed surveys were relied on the high-resolution LiDAR measurements for 12 years. And now, once again, to emphasize the core idea of this study is the alongshore sediment transport pattern and littoral cells. And if we now observe the results based on these 3 different input data sets, first what we can notice that different data sets lead to almost identical patterns along the study area. The largest long-term average alongshore sediment transport occur headlands, which is expected, and in the interior of Tallinn Bay, the sediment transport rates are by an order of magnitude smaller compared to the coastal areas more to the west. And to highlight here that this one set of estimates produced using this simplified scheme for evaluating the wave properties and the wave model WAM, this 1-point wind, still follow reasonably the longshore variations of the sediment transport. And they also give the similar results for the interior of Tallinn Bay simulations using model winds by ERA5 and Baltic 65. The variance between 2 distinct wave datasets applied to this ERA5 and Baltic 65 applied to the identical grid and model configuration is limited to the maximum difference of about only 15% for entire study area. And these 2 projections of bulk transport almost coincide most of the study area. This feature, I think this suggests good consistency in these wind data that drive the predominant wave system that drive the majority of the annual sediment transport. The ratio of the annual net and bulk transport provides information about the direction how the sediments are moving of the littoral drift. And most of the study area, this littoral drift is predominantly counterclockwise, aligning with the anisotropy of the wave and the wave fields in the regions. There are also few exceptions. These occur west of the Kakumäe Point, also in the interior of Tallinn Bay, Kopli Point, but these exceptions are mainly due to the different orientation of these coastal segments. And in the southern part of Tallinn Bay, this area hosts littoral drift with varying directions. And this leads to the formation of distinct small littoral drift cells in that one sediment compartment. The pattern of potential net sediment transport along the study area allows for us at least first approximation to identify the main littoral cells. The zero crossing marked as yellow circles, they indicate the convergence areas of sediment flux. In the nature, we can see those as sandy beaches or where the sediments are accumulating. And the zero upcrossing points, these reflect the divergence regions, and also they can be considered as borders between the neighboring sediment compartments. The sediments are moving from that point to different directions. And these points, over the period of interest we have considered, they have stayed stable, and these points on these theoretical calculations, they actually match with the major headlands and interiors of bays. And now to summarize all these results, this is illustrative scheme of the main sediment compartments in the study area. We can notice that the major headlands such as Kakumäe, Kopli and Paljassaare divide the sedimentary system into practically isolated sediment compartments. There is these 4 main sediment compartments with typical size of 10 kilometers. The interesting part or interesting cell in that figure is this Tallinn Bay sediment compartment that hosts a complicated pattern of net transport, and it is extensively interrupted by several engineering structures. And one interesting finding of this study was that in this coastal section from Rusalka to Pirita harbor, it's a straight coastline, one invisible divergence point appeared in that area. So why I'm stressing that is usually we wouldn't expect that that divergence point occurs in straight coastal area. But this became visible here, and this impact of the stable divergence point on the more to the north on the picture becomes evident of the accumulation area near Rusalka monument. And that this Rusalka area is like accumulating or at least stable, this is confirmed by the high-resolution measurements on the dry beach. We can notice that over the 10 years, this beach area or accumulation area has been stable, or even some parts maybe has increased sand height, beach height. And the other major accumulation area is in the southern part of Tallinn Bay is Pirita. The same story here. This beach area has been stable. There has been a slight increase of sediments over 12 years. However, here, the estimations, these theoretical estimations of longshore sediment transport reflect strong longshore transport in the northern part of Pirita beach, which in theory should mean that this area should suffer at least some extent to the erosion, but this is not the case in Pirita. What keeps this beach area stable across the entire length seems to be the combination of 2 wave systems. The infrequent strong storms with high waves occur together with high sea level, and they transport sediments towards south. And in normal conditions, when the low waves occur and the sea level is not high, these waves are able to transport back the sediments to the north, and therefore stabilizing effectively the northern part of Pirita beach. And I think it's important here to mention that for this complicated geometry, these individual coastal areas, if you want to have detailed understanding how the beach is functioning, we really need to incorporate wave and sea level information, and even more how different wave systems interact with the background sea level. And some conclusions. The sedimentary system on northern shore of Estonia is naturally divided into almost isolated littoral drift cells. These cells are often represent one bay that is deeply cut into mainland, and these sediment compartments are separated by major headlands. The set of man-made structures generates additional division of the system into subcells, and a stable point of divergence of wave-driven net sediment transport exists in almost straight coastal section on the southern coast of Tallinn Bay. Thank you.
So, any questions to Maris? So, I can. Okay, please. The microphone is coming. Yeah.
Thank you very much. Very interesting presentation. Thank you very much. So this model of yours, it is not taking into account the sediment grain size or the sediment availability. It's based only on wave dynamics.
Basically, yes.
All right. So everywhere where you can see the convergence point, there is actually accumulation of sands and the beaches.
In our study area, yes, these convergence zones are matching with actual beaches or bay heads where the sediments tend to accumulate.
All right.
So these theoretical estimations match with reality. So that gives like good results that we can at least have this idea where the sediments inside what location they are moving.
Mm-hmm. And what is your next area where you're going to apply this model?
Next area will be presented by the next presenter.
Okay, thank you.
Yeah, thank you. So I totally agree with very interesting work. One question about, I have a story when I come to my presentation about climate change. So what might the climate change affect? We have maybe more waves, different waves. Any idea? Anybody has done any work about what?
No, there are not work yet about this sediment transport, but if there will be changes in the directionality in wave systems, it definitely affects sediment transport, and these points of divergence and convergence, they may shift to other place, and we will see totally changing dynamic in coastal areas.
Yeah. And there's nothing actually, not much we can do, I assume.
Yeah, that's true.
Okay. Thank you.
Thank you.
Okay, one more paper to go, and Mikolai Jankowski, also from Tallinn University of Technology, continue about the same topic as we heard about model rates of potential Balkan net sediment transport along the Gulf of Riga. Gulf of Riga, so please.
Okay, so hello, my name is Mikolai, and I will talk to you about the very similar method associated topic to the previous one, but focusing this time on the Balkan net sediment transport in the Gulf of Riga. So, as for the bit of introduction why this research is even being done as part of my PhD, is to quantify and recalculate the sediment transport rates and find the divergence-convergence cells to compare against the previous study that was quite a while back now, from 2014, this particular figure, which has been done at a resolution of about 5.5 kilometers, which, while good to get the overall trends. It's not sufficient enough to analyze the finer scale features of longshore sediment transport. Now, regarding the methods, the background wave model that was used for the calculations is the aforementioned SWAN model, which the accurate setup of is already described a bit further with two published papers that I have linked here, one already fully published and the other was recently accepted into Oceanologia that focuses more about the variability in the climate of Gulf of Riga. Now, when it comes to the grid system that we've used in the wave model, as it serves as the basis for the longshore sediment transport one, it uses the resolution of up to 560 meters after setting up a triple nest system, the main running the entire Baltic, the second level running the entire Gulf of Riga, and the finest that I have put very scientific numbers on, 1, 2, 3, 4, are the 4 subgrids that I have selected in order to start my recalculation. Now, how the wave data point selection works is essentially I look at the storm values or the top 5% of wave heights, which I usually then compare against what is the known beach closure at that location in order to select a suitable point of all the wave values. And later on the sediment transport is calculated along the selected grid points. This here is the 1 nautical mile grid that we have for the entire Gulf of Riga, while I focused on with the further results on the smaller ones. Regarding the methods, you have already seen this slide. You already know what this is all about. But just as a reminder, we utilize the CERC method from the Coastal Engineering Research Council, which gives us the potential for longshore sediment transport. And based on the wave parameters, which I mainly take from SWAN, the wave direction and the wave height, then placed against the angle set at the relevant coastline. But as it was slightly hinted with a question, there is one method limitation for this, which is sediment availability. As for the entire coastline, the model runs on the assumption of availability of fine-grained sediments, which will not be the case when going, for example, to the coastline of southern Estonia, where we will have mainly larger pebbles or rocky shorelines. And the potential transport for finer sediments will tell us that there is a potential for sediments to be moved there, but not that it exactly exists in reality. That's the aspect of this particular research. And this figure you also already seen, because we are duplicating this session, it seems. But it is a general guideline for how to read the net transport figures developed by Viska, that when you are standing on the coastline and looking out to the water, anything in the positives moves to your right, anything in the negatives moves to your left. The line crosses upwards, then it's a point of erosion. If it goes downwards, it's a point of accumulation. And that's the more or less summary guideline of how to look at the net transport figures. Now, when it comes to, I sub-selected 2 of my subgrids in order to keep within the time limits. And I have taken the Roja grid, which goes more or less from Kolka Cape until the harbor of Engure. In this one, this is the bulk transport measures. We can see that there is a significant decrease after passing the Kolka Cape, which is what matches the previous studies in that area, as well as there is a relatively stable amount of bulk potential transport going along the coastline south of Kolka Cape, with a noticeable decrease, for example, by Merstrax, where we know that there is pretty much almost a halt of sediment transport. But when it comes to the net transport, the figure is slightly different, as it now gives us a little bit more in terms of direction or the points of erosion accumulation. Around the Kolka Cape is one of the most significantly noticeable, just after 20 points drop in sediment, not drop, but the point of erosion of sediment transport, which is where usually the famous pictures come from that have fallen trees because of the sand being washed away just around the Kolka Cape. And further along there is a point where the sediment transport stops before the point of Port of Roja, as well as another one where the coastline angle shifts to a certain barrier for longshore sediment transport just around Mersrags area, after which it continues relatively in a continuous manner along the coastline. And the secondary one that I decided to take is the Pärnu Bay, which, and this one, please excuse the numbering going in reverse, because it was the first grid I selected, and I selected in the opposite order to all my other grids. But in this particular case, we have the range from Kabli in the south going to Hobesalu and the western coastlines of Estonia. And here the main feature of it is that sediment transport slows down going to into Pärnu Bay, where following the longest waves usually that can even enter the bay from the south to southwestern direction, makes sense as it making it final destination for all the bulk transport and net transport, meaning that there is very little moving longshore in the Pärnu Bay itself. After Pärnu and going to the west, there is an increase to ridiculous values of bulk potential sediment transport, but this is why I wanted to keep it as a natural limitation to show the limitation of the model itself, because when it comes to incorporating sediment availability in the southern coastlines of Estonia, there isn't that much fine sediment. In fact, it's mainly rocky shores and large pebbles, meaning that fine-grade sediment model will give you results, but they actually don't contribute as much as we want them to. Just tell us that the wave climate could put a lot of sand moving if we dumped a lot of sand there. And when it comes to the net transport, a similar pattern can be seen when the transport is relatively continuous along the coastline towards Pärnu, going from the south, after which the pattern more or less reverses in the center of the Pärnu Bay, leading towards the position in that area. And further along, there is one other feature that can be easily noted with certain points of reversals to the west of Pärnu, which I have put also in one more figure that I have decided to abridge the more or less findings that I have. So, the significant trends that can be observed in the final resolution study that I have been doing so far is that to the west of Kolka Cape there is very large potential transport and very large known amount of transport happening in that area that more or less slows down and around Kolka Cape where it's pretty much cut off and then continues in a relatively stable manner southwards until the very south of Gulf of Riga, but at a much more moderate rate. North of Riga, around the point where you can see the box with 100 and to the south of it, there are several points of reversals of sediment transport, interconnected sedimentary systems that have been previously described in some literature that I have listed, which generally gives a good idea that, yes, the model should be doing something right in that location. And the last aspect of it is that the Pärnu Bay, while it experiences some accumulation and they have a need for harbor dredging, based on sediment availability along the coastline itself, that is not the main source of their needs to dredge, but it's more associated with the river Pärnu inflow, the position of sedimentary material in that area. And while for a technical view to the west of Pärnu to see that the longest waves will come from the opening of Irbe Strait and essentially split around the headline to create the potential sediment transport cells in that area, the availability of the sediment makes that calculation rather unnecessary, so it's included this time as an anecdotal element. And concluding remarks and future goals. In this research that is still currently ongoing, there is reasonable agreement in magnitude and directional components of the transport, and the higher resolution reveals certain aspects that have been previously described or studied with enhanced clarity. Now, when it comes to the future goals that I'll probably go back to working on this weekend, is refining the results, as there are still several areas of improvement in terms of model quality and picking the better associated point or enhancing the correct angle of the coastline that will reflect the reality a bit better after those are included. And extending the methodology further along the coastlines of Latvia, Lithuania, and potentially going to incorporate the full range of that previous study until Sambian Peninsula. And if I don't burn out completely by that point, I'll continue also along the Polish coastline. And that pretty much summarizes it. Thank you for your attention.
Any questions? Yes, please, that's behind.
Thank you very much for the presentation also. So thank you, Maris, if it's correct, for the presentation. Just curious about the in situ measurements. How did you measure, and since it covers a really large area, and how much confidence you have in the measurements, or like the uncertainty in the measurements?
When it comes to the in situ measurements, there was the plan where we have taken some equipment, I believe deployed, I don't quite remember if it was Latvian or Lithuanian coastline. But the problem with taking the in situ measurements for sediment transport tends to be that once deployed, a storm comes along and then it buried everything under like 3 meters of sand. And we stopped getting data for in situ measurements. But when it comes to most of this analysis, it's essentially calculating the potential and then checking in literature to compare against the modeled rates or observed rates in previous studies. But it didn't incorporate for this larger area any sort of new in situ data.
Right, so it's not the aero scanning or anything?
Didn't use so far, because it would be useful, but I haven't yet.
Right, I understand the measurement equipment getting swallowed by sediment, that could happen. But thank you very much for the good presentation.
Okay. Any more questions?
Yes, thanks for fascinating presentation, this and the previous ones. So there's a lot to think about. My understanding of these coastal processes is that there are two types of sediment transport. One is alongshore, what is perfectly described in the models that have been presented now, but an important component is also a cross-shore transport. And the big storms, and this is when the main erosion occurs, and the sediments and sands are really taken offshore, several kilometers. And then during the low storm, or during the times when there is not much of the storms, the sediments are gradually moved back towards the shores, and then that's when the equilibrium is restored until the next storm takes sands offshore as well. So how do you account for this onshore-offshore transport in your longshore transport models? Is this somehow counted, or do I talk about something else?
I have it essentially planned as a future aspect for adding to the model, because at the moment this is essentially a Eulerian system looking whether stuff moves to the left or to the right along the coastline. When it comes to incorporating further information with the cross-shore component, I plan to start working on, for example, looking at the Irbe Strait and Kolka Cape area, and based on the wave resolution and the potential transport that I have there, to set up a Lagrangian domain and see where exactly the sediment is drifting off northwards, for example, from Kolka Cape, for how much is going exactly eastwards, and where it is more likely to end up as a deposition area in there. So that is an ongoing aspect. For this, it's focusing essentially on giving better insight on a previous study to give the potential of longshore one.
Yeah, I think that would really strengthen your models, because it's very likely that this longshore transport is happening actually in zigzags.
Mm-hmm.
Okay, thanks very much.
Okay, thank you.
Anything more?
I can escape.
Thank you. Yes, you have done your part, yes. Thank you for every speaker. It was very interesting, and I learned that although there's many types of transport, I'm expert in maritime transport, but that's only one transport we have in the ocean, so very nice to learn something. Good, and we have a lunch break, and we come back at 2 o'clock. We have 50 minutes break, and lunch is somewhere here, I think, nearby. It's over there, yeah. Thank you for everybody. See you in 50 minutes.
Welcome back to session 3. My name is Hans Bies. I'm going to be the chair of session 3. We're going to start with a keynote, simulation tool for winter navigation decision support in the Baltic Sea. It's presented by Pentti Kaijula from the Aalto University. So please.
Okay. So hello again. I'm back here. Actually, I'm as can be seen, I'm both in Aalto University but more nowadays in Tallinn. So full professor in Tallinn and still some activities in Aalto, but slowly being in Tallinn. So, but this work has been done mainly in Aalto University, but we have applied the tool to think about how many icebreakers Estonia will need until 2050 year. So at the end, I will tell you how many icebreakers you need. But I will first go through the tool. It's a long process. We have been developing it almost 10 years, actually, on some European Union projects. A lot of people have been involved. So we have my colleague Masura, my young professor in Aalto University, Lulia Ling, and Alexander Kondrarenko, our postdoc students in this. So, why we have the tool? Because we have a big challenge. We should have a tool to evaluate what decision-making, how many icebreakers Finland will need, and how many icebreakers maybe Sweden will need, and how many icebreakers maybe Estonia will need. And that's the main motivation to make a simulation tool. And there are big changes happening. As we know, we have climate change. It will have a big effect to the ice. And how to take that into account. And the other big effect that this ERI ships means that there's more environmental friendly ships and they have less engine power. And maybe the hull shape is not optimum for icebreaking, so we will have very bad ice-coring vessels, more very bad ice-coring vessels, but very good environmental vessels. So what is the effect to the icebreaker capacity we need? So these are the two big questions what we want to answer with this tool. And typically, this is just to show you how the icebreaker operations in the Bay of Bothnia is coordinated between Finland and Sweden. It's a very close cooperation. Can you see it here? Yeah. Here you can see that they have they call it IPNet, internet-based system. Then they can get once a day a satellite picture about ice, and then they can see from this internet-based system that where the vessels are going, what is the next harbor, what kind of vessel, where the icebreakers are. So you can get immediately very nice picture which icebreaker to assist next vessel. So that's how the icebreaker captains who is in charge of this program, that's the tool they are using every day. But it's a daily based tool. They use it very efficiently daily, but our aim is to think about future. That can we simulate the ice conditions, can we simulate the icebreaker operations, can we simulate the cargo vessel operations in ice, so that we know up to next 10, 20 years what the traffic will look like. So that's the background why we're using it. And there are a lot of challenges. Nobody else has even tried to make this kind of a simulation tool, as we heard from Tarmo, that every simulation model is wrong, but it can be useful. So, and in our case, it's very complicated system to simulate varying ice conditions, varying vessels, and how the icebreakers are working. Icebreaker captain knows very well how to assist the next vessel, but how we can give that icebreaker captain decision-making process to the computer. Let's see. We are still working. We have some models, but still we have done a lot of interviews for the experienced captains, and let's see. So there are challenges, and other than this,
ice conditions are every day different and every winter different. We have this kind of a very hard winters on the left corner. When the whole Baltic Sea is frozen, it happened last time 1987, well, some years ago, but not so long time ago. And I think it's still possible that we have the whole Baltic Sea frozen, and then we have a number of challenges. But of course, nowadays, typically, we have much more mild winters. We have only ice on the very north and very east. And then sometimes, on average winter, we have the Bay of Bothnia is frozen and Gulf of Finland is frozen. So that's an average winter. So, but we have to think about the effect of climate change on the ice conditions and varying ice extent. But anyway, the main message is that there's a big scatter in ice every winter is different. So our simulation model, we call it agent-based discrete event simulation. We discretely simulate every event happening between the icebreaker and the cargo vessel. And we simulate the speed of cargo vessel. When we know the engine power of cargo vessel and how shape, we can get a rough estimate how thick ice they can break. We call it HV curve, it's ice thickness, ship speed curve. And we change ice conditions, we change the waterway dirways, and we have 1 mile per 1 mile. We heard about in previous presentation that this environmental data, like ice conditions, is 1 mile by 1 mile grid. So we are using the same 1 mile per 1 mile. So in that 1 mile per 1 mile, we have the same constant ice conditions, but the ice conditions are changing along the fairway. And we simulate everything, cargo vessels, icebreakers, and then we have done some validation. Well, background for you, if everybody will know that we in Finland we have at the moment 7 icebreakers plus Kontio, so we have Urho class, 2 Urho class vessels getting very old, Otso Kontio class, quite old, but not so old, and then we have Nordica Fennica multipurpose vessels. And the newest icebreaker is icebreaker Polaris, LNG vessel built in 2016. So we have this is our fleet. And of course because these Urho class vessels, they are getting soon 50 years old, so it's getting to the limit, but we need government funding, as we discussed about money, so at the end, so icebreaker is 100 million euros, so let's see when we get money from government. Update, they are still doing very well, I think, but anyway, that's the background. And then the challenge for us is this kind of graph. I'm sure this experienced captains know this very well, like Jukka. So, and when we are in opens, the first part is open water speed. In open water, we quite nicely know that it's constant. So the ship speed is, when you have the same engine power, the ship speed is constant. But when we come to the ice part, then the challenges start. So many things can happen. The speed will decrease, it can get stuck in ice, it has to wait icebreaker assistance, then icebreaker assistance has to do some towing, and then leaving it again, and then again it goes independently, and so. And this is only a few hour drafts showing the challenge. When we want to simulate this kind of a dynamic system, there are a lot of challenges, and I hope I can give you some indication about the challenges. But this is only a few hour craft, quite old one, MS Kemira. The ship I was on board a lot because I did my doctorate thesis being on board and measuring ice loading. So it's only a few hour graph. And this is how our simulation model works. We make these dirways. We think about where the vessels can go. And icebreakers, every vessel is following these dirways. And then we have HV curve to determine the ship speed. When we know ice thickness, for every vessel we have a HV curve. When we know ice thickness, we know what is the ship speed in independent navigation. Independent navigation means that it's alone in ice, so it has some speed, but typically it's behind an icebreaker, and then it has a much higher speed. So we have 2 types of curves. in level ice and behind an icebreaker. And then ice conditions, they defined by equivalent ice thickness, so we only use one parameter, come back to that. And we can simulate this icebreaker assistance in convoys and towing and so on. And this is a typical H-sphere curve. How we define it, that we have ship speed in the y-axis and level ice thickness in the x-axis. So, and this kind of for icebreaker, this in that case 2 meter ice is the maximum ice thickness. So then the speed is 0 in level ice. But behind in a channel, behind an icebreaker or an open other channel, so it can go much thicker ice. So for every cargo vessel we have about 40 this kind of H-sphere curves. Of course, for every icebreaker we have this kind of curves, and then for every cargo vessel, so about 40 different curves. When we know the enzyme power, hull shape, so we have some simple calculation methods to get roughly right curves. It's not totally accurate, but good enough. And then let's see, can I show you how it works? Yeah. You can see that how the ships are going. So the different colors, this is a schematic. It's not a real case, but it's a schematic picture about different ice thickness. And as you can see how the ships are moving, they are coming from open water to this kind of where the ice will start. And we get this arrival time from AIS data. And when we know the arrival time, we start to simulate how it then goes forward. And then it goes to the harbor, stays for a harbor for a while, and then leaves again. And then we simulate from the harbor to the ice edge, typically in a Vaasa, Merenkurkku, Kvarken area, so typically where we don't have any ice. So that's how it works, that we simulate every event, every vessel, every event, and then icebreakers are waiting somewhere, and then when they know that ships are coming, they start to move towards assisting. That's how it works, okay. And then how we get these HV curves, we have done a lot of numerical simulation tools, actually long history. Here we can see that one challenge is that when we have a moving ice, this ice channel is not open. We have a wind, and the channel will be closed, and we have a totally different resistance. So we have made tools to take that into account as well. So that's why what we heard about this from FMI, that we're also very happy to know the ice pressure and ice movement in our model. As of course, we want to know ice thickness and other parameters. And then how to validate our models, we have our own ice tank in Otaniemi campus, so we can do model scale testing. Here is one example about, we call it double acting vessel. It goes stern ahead in ice and forward in open water, so they can optimize the hull for open water going forward, and they only go stern in ice, so that they only ice strengthen the stern part. So it's more optimum for open water. And of course, this kind of a model scale testing as such is a big problem, how to scale. Typically the model is 1 to 20, so we have to scale the ice, and that's a problem, how we can make 20 times thinner ice and 20 times weaker ice than full-scale ice, and that's a big that's the main talent in ice model scale testing. Okay, but we have a theoretical modeling about ice breaking. We think about physical models about how ice breaks, and then we can validate the models with testing. And here are some examples about the validation. So into ice thicknesses vary a little bit, something like 30 centimeter and something like 60, 70 centimeter ice. So we get quite good accuracy, even though I think our simulated results give a little bit less, but about 10 to 20% accuracy to evaluate the HV curves, and that's enough for our simulation purposes. And then we have done a lot of studies about different ship types. Different ship types. So we evaluate when we know the main dimensions, length, breadth, and drafts, and hull shape. So we can evaluate the ice breaking capability, and then we can get a lot of this kind of HV curves for every different vessel, and we have about 40 different types. And then we have developed some regression formula that when we know the main parameters of the vessel, like the main dimensions and some important hull angles at the bow, length of the midship section, and this kind of parameters, so we have a very straightforward, simple regression formula to calculate these HV curves very quickly. And then we have different curves for different purposes. Okay, then after this HV curve challenge is done, then we have a very big challenge about equivalent ice thickness. So if you have typical ice picture, this is a typical ice in the Baltic Sea, can happen in Gulf of Finland, can happen in Bay of Bothnia. And we want to make only one parameter. As you can see, we want to use this kind of equivalent level ice thickness in our calculations. So, and the idea is that we try to physically simulate the ship resistance in different ice conditions. Like here we have a lot of ridges and some new ice, very thin new ice, and a lot of ridges. And then we numerically simulate the ship performance, and then we make equivalent level ice thickness that we get the same simulation results. The speed of the vessel is the same as it is in more complicated ice conditions, because our simulation tool cannot, it has to be simple, this HV curve. We have only one parameter, otherwise it gets too slow. And then to do it, here's an example about, there are many ways to calculate equivalent ice thickness and a lot of different formulations, and depending on what kind of ice you have different formulation to do it. But here's very simple, we call it equivalent volume thickness, that we have, when we have ridges, so typically we have ridges above the water and below the water. And ice density is 0.9. It means that 10% of the ice on this kind of a block, when we have a lot of ice blocks together, 10% is above the water and 90% is below the water. And as we cannot simulate, we cannot numerically make this simulation tool, it's too slow to simulate every ridge. So we change it. One way to do it is this volume thickness, that we just calculate the total volume of this ridge ice, and then we increase the thickness, as you can see here, that this is a level ice thickness, and then the thicker part on the right is the equivalent level ice thickness. So that's the main idea how we do it, and we have again a lot of different methods to do it, and a little bit also challenges what kind of methods always to use, but maybe you understand the basic idea that we use for ice conditions. We only use this kind of equivalent level ice thickness is our main parameter. So these are the basic principles of the model, and then I give you 2 or 3 case studies how we have applied it. There's one case study is from Bay of Bothnia, and then another case study is for Estonia. So typical ice conditions in the Bay of Bothnia can be 67 centimeter thick ice, and you can see that there's Otso, Kontio, Urho, Finnish icebreakers, and then Frey and Atle and Ymer, Swedish icebreakers. So we take that into account, and then when we know the traffic, we start simulating. And in a typical 1 month period, there is few hundred vessels. There is few hundred 1A ice class vessels, and a little bit less 1A super ice class vessels. So 1A means that it can navigate independently, relatively thin ice, let's say up to 30-40 centimeter. This one ice class 1A can roughly, but one ice class 1A super can navigate 70-80 centimeter. So a little bit better enzyme power, better hull shapes. And then we simulate, and one important parameter is waiting time, because our government is collecting fairway dues. Every vessel coming to Finnish harbor, they have to pay about 10, 20,000, 30,000 euro, depending on the ice class. And whenever they visit Finland, and government is collecting money, and government is using that money to give icebreaker assistance. Icebreaker assistance doesn't cost anything. It's today free. But then when government is collecting this visit fairway dues, as they call it, they have promised that the maximum waiting time for cargo vessels is 4 hours. That they guarantee that our icebreaker system is so good that nobody don't have to wait longer than on average 4 hours. It can be sometimes longer, sometimes short, but on average. And it works quite okay on a normal winter, hard winter. We have some challenges, but the most important result here is that when we simulated the waiting time for this 1 month period, and then we compared, because these icebreakers are collecting the waiting time data on this IPNet system, and we found that our model, even though there are a lot of challenges, in that case it was only 2% error, and of course it's almost too close to be actually too good, because we have some other simulations. I think, in my opinion, 10 to 20% accuracy is, but it showed that it basically, our simulation tool is not right, but can be useful, as we heard, because you get something out. And another very important topic today is this environmental cargo vessels. There are more and more vessels coming who will fulfill these environmental requirements, meaning that they have less engine power, and they have optimum hull for open water, but not optimum hull for ice. And we make a quick estimation that if you have, it's from 0 to 100% AD vessels. Now we have present waiting time is something like the overall waiting time, we calculate everything together, it's about 1,000 hours today. But if we have 20% AD vessels, waiting time is double. If you have 50% AD vessel, waiting time is triple. And if you have, let's say, 70%, which might happen in near future, this waiting time is 7 times higher than today. It means that our winter navigation system works quite nicely until the amount of these environmental friendly vessels is not too high. But as this is a trend, so this means that we might need much more icebreakers in future when these cargo vessels are getting environmental friendly. So that was one result of this study. And we have all been discussing, especially Ulla is not here anymore, but Ulla is very happy to think about this waiting time is one KPI, but maybe the whole economic for the society is another. Can we think about that as a KPI? Or let's say the total CO2 is one KPI. So now we are planning to, maybe we can use this tool to think about some other ways to think about the winter navigation system. And it's a lot of political discussions, because the harbors in the north, they want that we need icebreakers, even though it's very expensive to get cargo to we have a lot of steel factories, wood factories, and this lot of industry in the northern cities, and they will only work when we have this icebreaker assistance. And so if we go to this economic basics, it gets life very complicated how to do it. But let's see. At the moment we have done only the waiting time KPI, but let's see. We might develop the tool also for economic and CO2. Okay. And then another case study. we started this summer, actually. I think government Estonia is also thinking about how many icebreakers Estonia might need 2050. And to do the study, so we had done the model for the Bay of Bothnia, but during the summer we updated the model for Gulf of Finland, so we went through all the Estonian harbors and Estonian icebreakers. There are 3, Botnica, Tarmo and Eva. Botnica is now in Canada, but 3 icebreakers basically. And similarly, we got the cargo flow from AIS data, and also this Ulla Tapanese's group helped us to think about what kind of cargo flow we'll have today and future. And then from AIS data, we got the ships are coming in from the system from west, east, and north. And then we started to simulate how is the system working. Ice conditions for future we get from Baltic Maritime Institute. And the main, okay, I come back to that, but we simulated until 2050, what might the winters be. I come back to that, that was very interesting. And then we got the ice, and the blue color here means, by the way, the darker the blue, the thicker the ice. So we have very accurate, our simulation model is very accurate, 1 mile per 1 mile accuracy. So the darker the color, the thicker the ice, and that data we get from Baltic Maritime Institute. And then we started to simulate that the icebreakers, and we had 1 icebreaker in this Bay of Pärnu and 1 to 3 icebreakers in Gulf of Finland. And the question was that how many icebreakers we need on those areas, and the scenarios are given here. So we had on this study we had a lot of, we have Baltic, we have Akke Arctic, and some experienced icebreaker captains from Finland. So it was a consulting work. So we evaluated that the Gulf of Finland primary icebreaker should be about 30 megawatt icebreaker, so a little bit more than, I think Botnica is 9 megawatt, so a little bit more than Botnica. And then we can have one primary icebreaker in Gulf of Finland, let's say outside Tallinn or outside the other northern harbors, or we can have a second icebreaker 9 megawatt and third icebreaker 6 megawatt. These are the 3 scenarios we were studying, and always the Gulf of Riga icebreaker was 5.5 megawatt, like a current Eva, close to Eva. Eva is something similar. So that was our scenario. Then we studied different winters. So we had a typical mild winter on the left, typical normal winter on the right, and then very hard winter in these areas, meaning that the whole Bay of Pärnu is covered by ice, and as you can see the icebreaker possibilities, what we need. So that was so we simulated using these ice conditions. And then think about the future. So the main conclusion shortly is that, let's say that the hard winters are maybe today every 5 years, every 6 years, but in future, hard winters may be only every 10 years. But we can still have hard winters also here, and it means that we have to be prepared. It's the same in Finland and Sweden, that this hard winter is possible, even though the probability is less than before. So we have to be prepared on also for hard winters, normal winters, mild winters. And our main result is on this slide, showing that on mild winter, this 1 icebreaker in Gulf of Finland and 1 icebreaker in Bay of Pärnu is enough. The maximum waiting time is less than 2 hours. It's now minutes. 110 minutes means that less than 2 hours. But even on average winter, this 1 icebreaker in Gulf of Finland is not enough. We have the waiting time is about 8 hours average. But if you have 2 icebreakers in Gulf of Finland, on average winter, the waiting time is again less than 2 hours, less than 3 hours, and so on. And then on hard winter, even these 3 icebreakers in Gulf of Finland is not enough. The waiting times go something like 7 hours or something. So, but that's a very short, only few days, let's say, this kind of a hard. So the main conclusion from our study, I think this was also the final report what we did. We have delivered the report to Estonian government, and now we wait what they want to do. But so our recommendation on this research was that Estonia, we need 1 icebreaker in Bay of Pärnu and 2 icebreakers in Gulf of Finland. And of course, now we have, Estonia has Botnica, that can still continue, let's say, next 10 years. But Tarmo is very old, and then this Eva is quite old, so our conclusion is that also Estonia might need some new icebreakers. So that was our conclusion, and we don't, of course, know how it goes forward in the Estonian government. So that was a short summary about how to make a simulation tool. Very complicated topic, but after hard work and long time of many meetings, discussions with icebreaker captains, especially Väylävirasto in Finland has been very active to help us. So we have a let's say first version of simulation tool. We have validated it. Accuracy is varying, but 10 to 20, 30% accuracy. And we can use that to evaluate future icebreaker needs. We can think about the future economic winter navigation in the Finland, Sweden, Estonia, and then also future environmental regulations. What can it affect? What is the most best way to save fuel and more environmental friendly? Right. Thank you. And there are we have done some papers if you want to have a more questions. Thank you.
Do we have any questions? Thank you very much for your presentation. Any questions from the audience?
Maybe do you agree that 2 icebreakers is needed for Estonia, or?
Hello from the ministry side as well. As I'm familiar with your icebreaking analysis, what you have done in Baltic and together with Ulla. So thanks for this job as well. But my question is that what would be your advice that how we should get the new icebreaker? Should we build it up, the new one, or should we charter it like the Botnica? What will be your advice in that case? Thank you.
Yeah, of course, luckily I'm not in the Estonian government to make decisions, but chartering is good. The main challenge in chartering that when there's a hard winter, everybody needs icebreakers. So you can charter on mild winter, but on hard winter, chartering is more risky. Of course, it's much cheaper because then you can charter when you need, because when you make an icebreaker, it's very, very expensive. So chartering has risks are higher. There's no icebreakers on hard winter because it's hard winter here. It's also typical hard winter in other parts of the northern hemisphere. And then what was the other question about the chartering? And so and then other important is kind of, we call it multi-purpose icebreaker, that you use it for icebreaking in winter, but then think about something else. Like we have this windmill coming, like maintenance of windmill. It can be some exercise in summertime. So to combine that icebreaking in winter and then doing some other activities in summertime, I think that's maybe the best, because chartering is especially to get a good icebreaker when we have hard winter in Gulf of Finland, we have about 70 centimeter thick ice. It's very risky to only based on chartering. So I think at least one new icebreaker you might need to make it optimized for your purposes, and then maybe second or third can be chartered. risks are less. But it's very complicated problem.
Okay, Pentti, this is very interesting story. How about uncertainties in climate change? I remember that some months ago we heard that the Gulf Stream will stop 2025. Of course, it certainly will not stop, but it might weaken and cause to us some cold winter. So can we take somehow this into account as some special extreme?
Yeah, it's a very good question, of course, as well. I don't know what is the probability for this Gulf Stream to turn, but if it turns, it will have a dramatic effect to many other things. So we didn't take that into account because it will change everything. Then we have hard winters then hard winter is every winter almost. It has a very big effect. But then we can go by skiing. I can come to work I can come to my home from Espoo to Tallinn by skiing every day. So that's a good point. But hopefully it will not turn because it has a dramatic effect. I hope so. But I'm not expert.
We have time for one more question from the audience. If not, then thank you very much again.
Thank you.
Next speaker is Mingyang Zhang, also from Aalto University and Tallinn University of Technology. And he's going to talk about artificial intelligence-based digital twin models to monitor ship safety and efficiency. Please.
Thank you very much. Thank you, Chairman Hassans and other audience. I'm Mingyang Zhang, a postdoc researcher at Aalto University, Finland. Today it's my pleasure to attend the Gulf of Finland and the Eastern Baltic Sea Science Day 2023. Today I will show our current research, namely artificial intelligence-based digital twin models to monitoring ship safety and efficiency. My co-authors include Professor Kudiala and the Professor Hoderis. My presentation includes the background, research questions, method, and the results, as well as the applications. At last, I will introduce the conclusions from our research. So this slides present a simplified the flowchart for building a data-driven digital twin, and here potential applications in maritime industry. First, big data streams are collected at the real operational conditions, and then using the emergency technologies such like AI or mathematical technologies to capture the ship systems, and then replace the physics chip. Finally, we can see the AI or the mathematical model as the digital twin of the ship. Move your attention on the right side. The digital twin can be allowed for the monitoring and analysis, as well as optimization of ship operations in real operation conditions. It also promotes the better decision support for the ship safety, for proactive ship safety management, as well as the overall efficiency optimization of the ship. Watching this video, think about the question, how to develop a digital twin in real operational conditions. To the best of my knowledge, I think we should consider the complex traffic, complex waterway, complex operational conditions, as well as the uncertainties of the ship dynamic. So, however, the simplified mathematical method can't do it, because only using several coefficients to capture the complex system is difficult to achieve. So think about this question, can we using the deep learning method to capture the ship system and then optimize the ship operations in real operation conditions? Okay, next I will introduce our proposed method. As shown in this slides, the method includes two main deep learning layers. In effect, is two deep learning models here. There include 4 steps. The first, we should collect a lot of data at the SHE, and then to move to the layer 1. The layer 1 is used to capture the ship energy system in real observation conditions. It can be used to predict the ship fuel consumption, reflecting the hydrometeorological conditions. Move to layer 2. Layer 2 is the nature of layer 2 is AI-based, transformer-based deep learning method to capture the ship maneuvering system for the ship motions, 6 degrees of ship motions, as well as ship trajectories prediction in real observation conditions. After that, the trained deep learning networks, neural networks, can be used to replace the physics ship for the optimization in real world, like here. So, move to the step 1. In order to develop a digital twin for the ship in real observation conditions, the first step is big data collection. A wide range of the sensors are used to collect the data. As shown in these slides, the data streams include the navigation data, such like the speed course. The ship condition data is related to the laden condition or Baltic condition. Means well include the ship engine data about regarding to the propeller RPM or other stuffs. Means well is also considering the hydrometeorological data. Those data are related to the performance of the ship energy system and the ship maneuvering system in real operational conditions. So step 2 captures the ship energy system, because energy system and the ship maneuvering system are the most important system for a ship. So on the right side, a decision tree model was used to reduce the data dimension, because we collect 266 parameters from the Child data. We can't use it directly because the dimension of the data is very large. We developed a deep learning method, namely decision tree model, to reduce the data dimension, select the key influence factors on ship fuel consumption, such like ship draft, trim, ship speed, and so on. Move on your attention on the right side. The select key influencing factors on the fuel consumption set as the input in the model, showing here. There is the input. There is output set as the ship fuel consumption. After that, a deep learning method namely by LTM with attention vocabulary is used to capture the nonlinear relationship between the input and the output. After we capturing the ship energy system, we move to capture the ship maneuvering system. Ship maneuvering system is more complex. To recover the real operational conditions, AS data, hydrometeorological conditions data, and the bathymetric data are integrated. Ship maneuvering data and the operational conditions data as set the inputs, and such like the ship speed, heading, RPM, rudder angle, wind, and the wave. And the 6 degree of freedom is set the output as shown in the right side. A generative pre-trained transformer is used to capture the nonlinear relationship between the operational conditions and the ship maneuvering commanders, as well as to the ship 6 degree of freedom. The generative pre-trained transformer is similar to the ChatGPT. It's the same algorithm. So this is the first time we're using the big model to predict the shape motions. Okay, next I will present the case studies. The case studies was carried out focusing on a Baltic carrier and a row-packed ship, as shown in this slide. Baltic carrier is for the degenerating of ship energy system for the prediction of the ship fuel consumption. The row-packed ship is for the degenerating of the ship maneuvering system for 6 degrees of freedom prediction. For the Model 1, 2 years data is used to training and validate the model. The data include 53 different routes. The time interval is 1 minute. The navigation data, engine, ship operations, and the weather conditions set as the input, as shown in this the right figure on the slide. Ship fuel consumption set as the output. 80% of the data used for training the model, 20% of the data used for validation. The pre-trained model, the trained deep learning neural networks will be out of box. That means we can use it to predict the ship fuel consumption by giving the new data, new input to the model. 5-folder cross-validation is used to the data to validate the model. The meaning validate loss using the MSE is determined to be 0.02. The results quite good. The top figure shows the real data in red, predict data in gray. The middle figure presents the error rate in blue in time domain. The bottom figure presents the errors distribution, showing that over 90% of the errors are below to 4%, with the meaning error rate of 0.98%. The comparison studies indicated that the deep learning model can capture the energy system very well. For the layer 2, it's same. 2-year data is used to training and validate the ship maneuvering digital twin. The data include 500 different routes. The time interval is also 1 minute. The operational data and the ship maneuvering commanders are set the input to the model like this here, and the ship maneuvering set as the output. Same. 80% of the data used for training the model, 20% of data used for the validation. The trained deep learning model will be also out of box, so we can replace the physics model, such like based on the new input. Based on the new input, it can be used to predict the ship motions, 6 degrees of ship motions. By giving the stable input, the AI can generate the turning cycle. That means the stable inputs means that the RPM is same, rod angle is same. The ship will be operate in some cycles. Same 5-folder cross-validation also was used to validate the results. The meaning validation loss of the 6 degrees of freedom using MAE and RMSE is determined as shown in the table here. The left figure, you can see the real data is in blue and the predict data in red. The result shows that the fitting is very well. The AI can capture the ship features very well. Meanwhile, R-square value for search, row, and page prediction is more than 0.9. R-square for the survey and HIF prediction are 0.62 and 0.65. The comparison studies indicated that the deep learning model using transformer can capture the ship maneuvering system very well. Let's show the applications. We develop AI model. We want to use it. So we will give the new data to the trained deep learning neural networks. The data was collected from whole voyages from Vikava, Kandala, and anti-China. The right curve denotes the records of the ship field conception, like here. The gray curve presents the predicted value of ship field conception, showing that the trained deep learning neural networks can be used to predict the ship field conception for very long voyages of the ship. Meanwhile, it can conclude that the ship digital twin can actually capture the ship energy system for ship field conception prediction in real operation conditions. Next, we will talk about how to use it, because I think the model has the potential to improve the route, as shown in this figure. Between port A and port B, there has massive possible ship route. But which one is the best? Based on the iteration with the optimization process can help to identify the best and the most efficient ship operations and then reduce the ship fuel in real operation. Let's move to next. By using the digital twin of ship maneuvering system, can be used to predict the ship turning cycle by using the stable input. For example, we set the RPM is same and the roll angle keep at 1, 5, 10, 15 degree. As shown in the left figure, the right cycle denotes present the predict value of the turning cycle of the ship, and the blue cycle denotes the real data, showing that the transformer-based deep learning model can be used to predict the ship turning cycle. It also concludes that the digital twin can accurately capture the ship maneuvering system for ship motion prediction in real operation conditions. Meanwhile, it also can be used to determine the proactive navigation avoidance. For example, like here, the AI model can be used to simulate all the ship maneuvering instructions, then select the safe one. After that, deliver to the captain. We can use AI to convert the positive risk control to the proactive risk control for the ship in real operation conditions. Okay, I will conclude my presentation. Based on my understanding, the AI-based ship digital twin may contribute to safer and sustainable ship operations in Gulf of Finland. The AI can be used to predict the ship motions and ship dynamics, reflecting the hydrometeorological conditions. It also can be used to estimate the ship fuel consumptions for long voyages. It also has the potential to optimize the ship operations and the support to develop the intelligent navigation monitoring and the decision support system. Thank you very much. The research was funded by the EU project Retrofit 55. Thank you. Any question?
Thank you very much. Do we have any questions from the audience? Over there, please.
Once again, thank you for interesting presentation. I have a question. As we know from the world's biggest shipping companies or operators that the different indexes like ED, EXE, CIA, URN, they are not working in a symbiosis. What is your thoughts that how these digital twin systems can help to reach the goals? Thank you.
Thank you very much. Based on my understanding, the EOI or CI are the KPI for the ship operations, but those factors can be used to evaluate the efficiency level of the ship operations. For our research, we try to replace the physics ship After that, using the AI to simulate all the possible ship operations and then select the best one. In this case, we can save some, we can try to reduce the resistance of the ship in real operation conditions and reduce the ship fuel consumption.
Thank you.
Thank you. Thank you very much.
Okay, the next speaker is now Robert Epps from University of Tartu, and he's going to present towards sustainable biofouling management for recreational boating in the Baltic Sea region. There you go. Thank you.
So, it's nice to be here and to talk about sustainable biofouling management for recreational boating in the Baltic Sea region. Recreational boating, it is very much connected to the maritime tourism, naturally sustainable and things like that. So, and to proceed, first of all, as always, we need to keep in mind or know the multi-level governance levels. And according to European Code of Conduct on recreational boating and invasive alien species, the invasive alien species are currently identified as a major risk for native species and ecosystems on a global scale. It means maritime tourism is nice, but what is connected to that? First thing, in general, the biofouling management action shall follow the requirements of International Convention on the Control of Harmful Anti-Fouling Systems on Ships, IMO, and in case of leisure boats less than 24 meters in length, the challenge is addressed by guidance for minimizing the transfer of invasive aquatic species as biofouling, hull fouling for recreational craft. So it is just to start with, and then how the reality looks like is here. And here is just one example. It is the Pärnu Bay. And before, there was a nice balance between bottom life, and it is basically Macoma Baltica, which is filtering the water and improving the water situation for the people and others. And after mud crab arrived, there is Bennik communities. He is eating out mostly all of the Macoma, and the water quality is not as good as before. It's just an example to start with. And here is a number of maps of different non-indigenous species arrived. And for example, zebra mussels. First map, then tiger squid. You can see that it is almost all the way around the Estonian coast. Then Marencellaria species is a genus of annelids belonging to the family of Spionidae, and he is also occupying most of the, practically all of Estonian coastal waters. And here is round goby fish, which is, for example, eating a lot of Baltic herring. Let's say next generation on the spawning grounds. Atlantic rangia, Harris mud crab, what was mentioned already, here is mainly in the Pärnu Bay in the Gulf of Riga, and the results of his activity was shown before. So, and then it is the, how to say, the reality. We have the shipping, we have the boating, and as the result of that, we have this situation. A lot of changes based on new species coming in. And the next question is, okay, but what to do about that? We have here one running project, Baltic Sustainable Boating 2030, in a course of implementation of this Baltic Sea Region project. Baltic Sustainable Boating, making leisure boating in the Baltic Sea fit for the post-pandemic boating tourism market. The attention is paid also to outlining the issue of sustainable biofouling management for recreational boating in the Baltic Sea region, with aim to provide general guidance to policy and decision makers, experts, academicians, stakeholders, boaters and harbour operators in improving the competitiveness and effectiveness of existing maritime anti-fouling activities. So, and here is, we can speak a lot about this picture, but it is the vision for the sustainable boating in the Baltic Sea region. Here is also mentioned that keep out invasive species. So, but we need to proceed. And here are some technical details. Biofouling of leisure boats. We had the complete project, very important in this direction, proposal for the regional Baltic biofouling management roadmap. It is stated that leisure boats may act to a large degree as a vector of secondary spread of this between adjacent harbors, marinas, and other coastal regions. It is further added that marinas play a similar role as ports, acting as recipient area of new species which can be introduced there and spread further to other regions by fouled leisure boats. So, and then another document here, biofouling assessment protocol, the sampling in marinas by settling plates and scrapping samples is addressing the question to what extent marinas represent a risk in introducing invasive species via leisure boats through biofouling in the Baltic Sea. And here are a couple of images, settling plates to collect invasive, and here recommendation cleaning scrape for the removal of barnacles and other biofouling organisms, just to give you example how they look like. And Now we can go to the state that to deal with something, first of all, we need the vision. And regional vision, it is HELCOM vision. We all know that by heart. A healthy Baltic Sea environment with diverse biological components functioning in balance, resulting in a good ecological status and supporting a wide range of sustainable economic and social activities. It means our natural resources, ecosystem services are the basis for economic and social activities. So that's very good. And then next thing is, it was why, and next is what to do. Actions. Only actions can change the situation. Knowledge only is very nice, but knowledge only is changing nothing. Actions. We need the actions, and HELCOM action. Minimize the release of biocides from antifouling products in the marine environment, and preferably by 2027 replace the use of biocidal antifouling products with biocide-free alternatives on structures, equipment, and recreational craft in cases not already subjected to the international conventions on the control of harmful antifouling systems on ships when available and environmentally and technically feasible. Next action, promote the development and use of effective environmentally sustainable biofouling management techniques and antifouling systems on ships and recreational craft, including biocide-free alternatives to prevent biofouling by supporting related research and development activities in the Baltic Sea region. And HELCOM action, promote environmentally sustainable recreational boating, including the use of best environmental practices through education and raising awareness of both users and the personnel of marinas and guest harbors. Promote also green marinas and guest harbors by introducing eco-labeling of marinas and developing guidance and best practices documents by 2025 as a help for the marinas to reach criteria. So, and again, HELCOM action, strengthen cooperation with stakeholders in the development and implementation of sustainable biofouling management options by 2026 to minimize the introduction of invasive aquatic species, the release of hazardous substances and microplastics from antifouling systems, as well as enhancing energy efficiency. More clean they are, more energy efficient are our vessels. So, and also how to do that. And here, participatory argumentation and mutual learning. First of all, we have the proposal for regional Baltic biofouling management roadmap. Now it is already part of HELCOM documentation, and guidance provided by this publication is used by Baltic Sustainable Boating project, related participatory argumentation and mutual learning workshops to evaluate the biofouling management proactive and reactive best practices for conducting proactive inspection of the hull and the cleaning to minimize the attachment and accumulation of biofouling. And almost finally, sustainable biofouling management, participatory argumentation, and mutual learning processes. Argumentation and mutual learning processes are facilitating the common understanding among managers, scientists, regulators, decision makers, volunteers, and others of the social dimension of recreational boating, common understanding as a basis for Baltic sustainable biofouling management. So, we are starting with multi-level governance, and we are here with the common understanding as a basis for Baltic sustainable biofouling management. So, thank you very much.
Thank you very much for your presentation. Are there any questions from the audience? We have one over here.
Yes.
Again, thanks for a very interesting talk and sharing the beautiful maps, which contents perhaps wasn't that beautiful. But so if we look at these non-indigenous species along the Estonian coast, if we look backwards, so when these non-indigenous species appeared in our waters, is it a gradual process, or have been the certain times when things really got out of hand?
Yeah, thank you for the question. Let's say, historically speaking, we as a marine biologist also, we have marine systems research, have been fixing, different indigenous species coming in time by time by time by time. It means that they are already here, then we can see them. We normally not see them as a part of the holing. It means where they are already swimming and running around.
But then if we go back in time...
Yes?
Was there a specific time? So, for example, when Estonia opened up after the Soviet time, more boats were coming in, and then things, more of these non-indigenous species appeared, or has this been a gradual process starting already from the beginning of shipping?
Now I got your question. Answer is how they are appearing here. They are coming with vessels and boats. And as far as I remember, vessels have been running all the time, and boats almost all the time, at least by regions. Thank you.
Thank you for the talk. On one of your slides, you were mentioning anti-biofouling structures that they plan to use instead of the biocide-based chemicals. Do you know what is the active ingredient or let's say principal component in these anti-biofouling structures?
Yeah.
Thank you.
I could answer this way. Even when these slides will be available to all of us, you can see before in the low part of the slide some webs opening some documents. You can get the answer to that. Yeah, but this is very special area, quickly developing, what is clear that older things, old things, they are very dangerous for the nature. They are preventing falling, but they are killing the nature around. And that's why we have even IMO regulation about that, to prevent that. And then what are the new things? It is the industry is developing new things which are not dangerous, and it is improving, but there is no legal act saying that what is accepted, only what we have, what is prohibited. So, thank you.
Right. Thank you very much.
Thank you.
Okay, then we come to the final speaker of the session 3. This is Alexander Clausen from Tallinn University of Technology, and he's going to present Underwater Soundscape of the Gulf of Finland, please.
Thank you, Mr. Chairman. Good afternoon. I have pleasure to talk today about a specific question, which is underwater noise and its impact on the marine life in the Baltic Sea. How does it run? Next. Oh, sorry. So this research was mainly done in frames of Helcom Blues project. And this project, the scheme of this project is on this slide. And underwater noise was just one part of this project. So in frames of this, we have made assessment of both impulsive and continuous noise. So I will start with impulsive noise. Impulsive noise is mainly related to human activity such as underwater ordnance clearance, as offshore constructions. There is not much offshore construction in the Baltic Sea, but there is a lot of other activities that can be seen on this slide. So in red, so here you can see zoom of the Gulf of Finland, and we have basically explosions here. And the number of these explosions marked here on this map is quite important, but you should consider that it is made for, this data is collected from a period of 5 years, since 2016 to 2021. And for other activities also, so there are activities, impulsive noise activities, but basically not so much when related to one specific year. To make assessment, the data of the impulsive noise is collected in ICES-hosted Helcom Impulsive Noise Registry. And every Helcom country is reporting the data according to their best knowledge. And here you can see the map of Helcom countries and their registry uploads. The space is not, some periods, some countries are not reporting much, and of course this should be improved. So the main problem actually is that registry do not have all the data to have like better assessment. But in general, we can state that good environmental status is not much perturbed by impulsive noise, and we are good with impulsive noise, since we don't have much offshore activities in the Baltic Sea. Next, continuous low-frequency noise, which is mainly related to the shipping. And here is the map of Gulf of Finland. You can see two different partitions. One, the upper one showing passenger fleet AES data during August 2023, and the lower one, cargo and tanker So you see it's two different passes, and it is possible to model shipping noise from this AS data, and it was done in frame of this BLUES project. Results of the assessment has been used also for in HOLAS assessment, and it can be, this document can be found in the internet. So next, I would show you some metrics which we are using to assess impact of continuous noise. Here on this map, you can see, so we have in blue is something which we can consider as natural noise. Natural noise is related mainly to surface waves and wind. Then we have in red shipping noise, which can be perceived in some particular point as increase of sound pressure level up to the total level, which is marked here by red dotted line. And so we can assess both total sound pressure level, and we can assess excess of total pressure level over the natural. And so in the next, we will use these two different metrics for the assessment. As for frequency ranges, in acoustics, we have broad spectrum of frequencies. And here we are focused on two frequency ranges, one for fish and one for marine mammals. Fishes are quite sensitive to low frequency noise, and so 125 kilohertz decidecade was used for assessment of impact on fish, and 500 hertz is more useful to assess marine mammals, as marine mammals are better, they have better hearing in high frequency range. So 500 is considered like so frequency for marine mammals. Next, during this, so we have made modeling of the sound pressure in the Baltic Sea. And assessment was done in these Baltic Sea sub-basins. And we have used monitoring data because, of course, we have model, but in order to have reliable model, we need to calibrate. And we calibrate sound pressure level model by measurement results. And this measurement data was chosen for 2018 as a period of better coverage of data, and this monitoring is monitoring points are shown on this map of the Baltic Sea. There is not much such places, but so in total it was a little bit about 10 measuring points used for calibration. Next, we need to agree what species are endangered by the noise. And these species should be noise sensitive, very well hearing animals. And in total for the Baltic Sea, so we have Baltic herring and cod, which are considered like most sound sensitive species. And for marine mammals, so we have all marine mammals here, seals, different species of seals, and harbor porpoise. Specifically for Gulf of Finland, we have seals and we have Baltic herring as indicator species. So we consider that if something goes wrong, it goes wrong first of all for these species. What effects we are considering on the animals? It's not so easy question to understand what are the effects of noise. So if we talk about total sound pressure level increased by the presence of shipping noise, we can say that it is a disturbance effect. Disturbance meaning that a marine animal or fish cannot make its daily life procedures, so something going wrong with this high total sound pressure. On the other hand, we have excess level. And excess is responsible for so-called masking, meaning that increase of anthropogenic noise so is hindering hearing and perception of what is happening underwater, because all marine species are very much relying on underwater sound and vibration. So these two different effects are used, and we are doing two different assessments, both for total and excess level. Next, we need to agree about what we call level of onset of biologically significant adverse effects, or LOAP. LOAP is a sound pressure level in decibels versus micropascal in water. And these decibels are known to produce significant effects. And these numbers are given here, so you can once more see that seals and porpoises are assessed for 500 hertz. But all total sound pressure numbers are quite similar. It's all about 110 decibels. As for excess level, we are using here 20 decibel excess level as a LOAP value, which is quite a lot of energy, because 20 dB, meaning that if you have perceived some object, some sound object, some source at 100 meters, with 20 dB, you can perceive same source at 1 meter. So it's 100 times shorter distance of detection. And next, we also need to take in this equation space parameters, space, time, frequency. So all these three parameters should be considered. For time, we consider that sound pressure level metrics are all median values. We consider that one unit of assessment is 1 month, and so we consider monthly median sound pressure levels. As for the spatial threshold is taken to 20%, meaning that if LOAP is exceeded at 20% of the assessed area, it is not GES. So here it is the scheme showing how it works for total sound pressure level, and in the same way we do it for masking and for excess level. Now here are some results. So what you see here is a map for 125 hertz in Gulf of Finland. This color bar is showing sound pressure level in decibels. And here we see in red area in which median SPL is exceeded. Taking into account all this area of the Gulf of Finland, it's not so big. If we do the same for 500 hertz, we practically can't see anything. So LOAP of 110 decibels is never exceeded for this particular March, in March 2018. By the way, it is the noisiest months of the year, because in spring, in early spring, sound propagation conditions in the Baltic Sea are the best. Now, if we go for excess level and masking effects, we can see it's a completely different picture. So the major part of the Gulf of Finland is in red, meaning that sound pressure level, natural sound pressure level, is exceeded by 20 dB on this part, at least 20 dB, sometimes it's even more. And if we look for 500 hertz and assessment for marine mammals, we also see in red, quite considerable part is in red, but it is below the threshold of 20% of Gulf of Finland. Now, next we can see what's happening, how this spatial threshold of 20% is exceeded during the year. And here is example of Gulf of Finland. And what you see here is two assessments made for 125 hertz and for fish. We see that in GS, we never attain this lobe value of 20%. As for masking, it is exceeded since January up to May, and it is also attained in December. So for quite considerable part of the year, we have this exceedance of 20 dB on more than 20% of the Gulf of Finland. And next slide is for marine mammals. For marine mammals, disturbance or total sound pressure level is never attaining lobe value. As for masking, it is also not attaining lobe. We can see some attaining sometimes 10%, but not more. However, if we consider that 20 dB excess level is too much, and 12 dB is also quite considerable portion of acoustical energy, in that case, this picture will change, and we will see that effectively, if we look for 20 dB as threshold lobe value, effectively in the Gulf of Finland we also have facing some problems. But nevertheless, it's both assessment for 1 year and for one particular month, and it can be different for other months and other years to come. Now for the effect, what effect might it have to the fish? First of all, if we look to the spawning grounds for Baltic herring are mainly next to the coast. And if you look to the right, excess level near the coast is non-existent. So low frequency noise do not propagate in very low shallow water where spawning of the Baltic herring is taking place. And this table is showing you overview of all the assessment of the Baltic Sea, including Gulf of Finland on the first row. So as I said, for marine mammals, according to metrics and lobe values that we are using, according to our criteria, in Gulf of Finland, marine mammals are in good environmental status, but fish is not. And this is all. In conclusion, I should say that this assessment was made based on TG noise work group and HELCOM recommendations. And Baltic Sea marine mammals are more sensitive to high frequency, which do not propagate as far as it do low frequency sound. And for this reason, it's not attaining spatial threshold. Baltic herring spawn in shallow coastal waters where they are not affected by low frequency sound. And the consequences of disturbing fish outside spawning areas are not clear for us now at this moment, especially when compared to the consequences of, for example, fishing pressure, which is quite considerable in case of fish in the Baltic Sea. That's all for me. Thank you.
Thank you very much. Maybe one question from the audience before we take coffee break? No? Okay, then we just take coffee, I guess. Thank you very much.
Just an announcement, yes, there will be coffee break. It will be slightly shorter than foreseen, so we recover at 10 minutes to 4. Is that okay? 5 minutes to 4, 10 minutes to 4. And instructions about how to go to evening snack will be given at the end of discussion. Welcome everybody to the discussion section or session, which is of course overly long. And this is why we decided to fill it with very good brains and very good speakers, so that others will not feel that it's all boring. We shall today have 5 announced participants and 1 intervention participant. The rules are simple. Every participant of the discussion will introduce him or herself and immediately provide a kind of thoughts, ideas, mission, vision, dream, statement, declaration, whatever you call, and about whatever you find interesting, possibly in the context of today's conference, possibly, but not, it's not mandatory. The participants represent quite many countries, and I start from the sequence how they are printed in the program. So Pentti Kujala, who is representing Finland and Estonia, Kai Myrberg, who speaks perfect Estonian but is Finnish, Hans Biks from Norway, Aivo Lepland, who is today representing Estonia, Loretta Kelpšaitė-Rimkiene, she was Estonian about 15 years ago, now she's Lithuanian, and a new face in the panel, Liis Kikas from Estonia, Ministry of Climate. You're welcome to pick up your seat. So the first question goes to the audience. Who should start? Any ideas? Oh, that was too tough question. Okay, Juha, you tell who will start.
Well, considering the talks and things we've heard today, I would actually like to have Kai to start since he hasn't been talking today yet.
Good. Okay, I can start. Is the mic, can you hear me? I have the microphone. It's working now. So I'm Kai Myrberg, originally from the Finnish Institute of Marine Research, but as Robert Flinkman said, the Finnish government did their best decision ever in 2008 to close the institute. And since then I have been in the Finnish Environment Institute and I'm a physical oceanographer. But in this Syke time I have been working with the so-called trilateral Finnish, Estonian, Russian cooperation of the Gulf of Finland environment. And so this cooperation started in 1968 as a cooperation between Finland and the Soviet Union. But at that time there was 3 cities which were strong in this cooperation, which were Tallinn, Helsinki and Leningrad. And from 1992 that was really true cooperation between the 3 countries, the Iberian countries of the Gulf of Finland. And then we had the first Gulf of Finland year 1996 and the second was in 2014, and the second one was very big, organized by Syke. And during this year we had the first bad signals from Russia, this occupation of the Crimea, and the year was somehow a little bit, so to say, it was firstly at very high level, the presidents were the patrons of the year, but of course after this event, and then this kind of ministerial level visits were cancelled. Well, anyway, we did during the year a lot of events, and the Gulf of Finland, this kind of report of the Gulf of Finland state, which was quite comprehensive. And what I'm concerned today is not only about what happens in Ukraine and so on, and what is Russian aggression against the rest of the world, but one thing which, if we come from the politics to the environmental scientists, one thing which we are lacking is the data flow from Russia. I know that HELCOM still gets some data, but of course during the coming years, if the situation keeps us as it is, we can just think about that the data flow will decrease, not increase. And so when the Gulf of Finland year 2014 has its 10 years celebration next year, I think that we should somehow discuss how this cooperation goes on without Russia. What happens if something positive happens in Russia? Are we ready to cooperate? Do we have the own network still available? And how we can then deal with the Gulf of Finland and the Baltic Sea status if we don't have data from Russia? What about if Aranda one day measures at our eastern point in Haapasaari some very high concentration of phosphorus, which means that the St. Petersburg water purification system has break down and things like that. So I think that we need next year some kind of meeting where also we have ministerial people, politicians, NGOs and scientists to work and to discuss together where we are now and what kind of scenarios we will have. I have discussed it in Finland with several ministries, but there is a little bit silence that nobody wants to use the word Russia anymore. It's like a forbidden word, but I think that we should discuss openly what will happen in the future. But that's what is my message for today. Thanks.
Thank you very much, Kai, and I knew that Juha was biased towards a Finnish guy. So now the second question goes to Arno, who can't be biased anymore because the Finnish guy had the word already. Who should be the next now?
Yes? Well, let's try how this goes. Is the microphone on?
Yes.
Yes, Aivo Lepland is my name, and I'm Estonian geologist, marine geologist, working these days mainly in Norway at the Geological Survey of Norway, but also I'm affiliated as a researcher, guest researcher with the universities in Tartu and Tallinn, and also the Geological Survey of Estonia. Being marine geologist, Gulf of Finland, I have to say, is a real Disneyland. There are attractions all over the place, and you want to take these scientific environmental rides again and again and again. So with all these complicated geology behind it, with the depositional basins, erosional areas, with the sediment accumulating in certain areas, being eroded from other areas, and then the salinity variations in a water column and the chemoclines and all sorts of clines developing both in sediments and also in a water column, it is a really unique environment that deserves close look from the geological perspective, both as a target for the scientific studies. Numerous fundamental scientific discoveries are yet to be made of the unique microbial ecosystems at the seafloor, formation of these manganese iron hydroxides on the seafloor that are both considered as perhaps the economic resource, but also as the environmentally sensitive objects that can cause the eutrophication and also all other types of effects. And then we have to put it all into the context of the current environmental state, and the seafloor and the geological processes really play an important role. Actually are the backbone of many of these processes, what we see in a photo column and down the food chains in a biology. So good collaboration that has been stressed throughout this meeting here is really the backbone of getting the best handle upon the unique resource what we have here as a common ground, Gulf of Finland.
Thank you, very clear. So the next question goes to audience again. So I target that to our Italian-Estonian guy, Andrea. Andrea, who you think should be the next now?
Perhaps Loretta can.
So I was when Tarmo said that the next who will choose is our Italian guys, more or less I understood that will be my turn. So when somebody asked me that can you describe who you are, I always feeling quite a big challenge on that, because I start my journey from studying physics, simple physics. Into comparison with the oceanography, physics is very simple. But I always wanted, and I was willing to work with the Baltic Sea. And my master thesis, the person who lead my master thesis said, okay, Loretta, if you want to continue with the Baltic Sea, then you should go to Estonia. The best oceanographers in all 3 Baltic states are there, and try a way how to do that. So, and that's how I end up in Estonia, and I started to deal with the waves and physical oceanography. And I always was jealous when I was participating in the Gulf of Finland days and listening the talks about how that our theoretical work can be applied for the governmental use, for how it can be translated to the simple citizens. And even if that Gulf of Finland days scientific events are very, in comparison with the Baltic Sea Science Congress, is very small and talks only about this small area, but we never should forget that it can be later broadened to the whole Baltic Sea. And the same issues can be found in different parts of the Baltic. Like, for example, as Kai already have mentioned, that now in nowadays situation, one day we can measure some phosphorus, increasing in phosphorus, and we know that it came from Russia. But that's issue not only for the Gulf of Finland, that's also issue for the Curonian Lagoon, because we don't know what may happen on our other side of the Curonian Lagoon. And Curonian Lagoon is one of the largest lagoons in Europe, not only in the Baltic. What will happen if Russians will decide that they want to have their own entrance into the Curonian Lagoon? It's less than 1 kilometer at the beginnings. For them, that's nothing. Polish already have showed that that's doable. And we should not look at Russia now as at enemies. They're still key game players in the Baltic Sea environment. And with the example of Gulf of Finland, Curonian Lagoon, and other places in the Baltic, we should learn and think and to prognose how we should deal with that, and looking forward to the future scenarios.
Thank you very much, Loretta. We still have some other international guests who are at least temporarily Estonians. So now I'm asking from the last row, Mikolai, who out of 3 is your choice as the next speaker? Mikolai is from Poland.
Yes, hello. I have no particular order of preference that I would go with.
You have to decide.
I know, it's a big pressure element. So how about going with Ivo Lepland?
Oh,
yes.
Already taken?
So I'll take another go.
Already taken.
Sorry.
That's a check.
I am horrible with associating names.
Yeah. That's a check where the students are following what is going on.
Yeah, follow the story.
Okay. Then how about simply going by a somewhat German-sounding name of Hans, even if it's not German?
Yes.
Okay.
Okay. Yeah, then I'm Hans Bies. I'm working at the NTNU in Trondheim, and I'm working together with Taumo at the moment and Loretta on investigating the effect of waves on the Baltic shores. And we in Norway have this EEA program where we cooperate with the Baltic countries. So it's a great opportunity for us to work together with an area where we, from NTNU's perspective, maybe not so often active. The Baltic Sea is for us far away in that sense. So it's a very interesting project for us. We have maybe a bit different perspective. We are, our main focus is maybe not the process itself, but we come from a methods point of view. What we try to do is we build numerical models that can represent the physics outside, so we try to represent it as closely as possible. So that's where we put our energy in most of the time. We develop software, and tomorrow we're going to show a bit how we are tackling this and how we try to work together here towards understanding the processes at the Baltic coast better. Yeah. Thank you.
Thank you, Hans. And then the tasks for people from audience is becoming simpler and simpler. So our Latvian guest, who was Estonian 10 years ago, approximately, Maja, who is your choice out of the two remaining ones? Great.
Me, okay. I didn't know it was, yeah. I'm Liis Pigas currently from the Ministry of Climate, but I must say that in the beginning of the year it was called before Ministry of the Environment. But now the restructuring, now I'm representing here Ministry of Climate, but still in the regarding marine environment relations, and actually currently I am a coordinator of Estonian HELCOM delegation, and also all so I'm pretty much, I have the main knowledge what concerns about Estonian scientists and experts participating in the large Baltic Sea protection work, and the HELCOM umbrella. So, and I have the marine background, hydrographer I am, and also environmental management master's degree. So I have the physics background, but also regarding the impacts of different human pressures to the environment. And I have been basically whole my career I have been involved with the Baltic Sea and sea environment impacts. So this is very my topic, and I am actually very happy that in current position I can work with policymakers and also marine scientists and experts, because I try to be this translator between the scientific research and because we see that our decisions must be really based on the scientific research. So. And also, as Kai mentioned, currently the work in HELCOM is very, let's say it's difficult, because as we all know, officially the work has been stopped, but still, fortunately, in official consultation among the European Union parties, who are also parties of the HELCOM Convention, we are still doing a lot of cooperation, and all the work is still ongoing. As also mentioned today, was the Baltic Sea Action Plan, and it was just recently in 2021 we took that new commitments above us, and we need to take into force 199 activities, and now we are actually lacking one partner of the convention, so it is difficult. We really try to, at least in written form, still ask for an expert level, get some input from the Russian parties, but it is difficult. And yes, the situation is that on the higher levels, we do not do such good cooperation anymore, unfortunately.
Thanks a lot. That's also a very clear statement, and I apologize to those nations who haven't had yet the opportunity to ask or to say who is the next, because only one in the panel has left, but you all have opportunity to ask later. As you may have recognized, it's first of all a very wide spectrum of people here, and most of them are like bridges between either different sectors or different nations or different countries. And the last, of course, but not least, representative of our community in this panel, Pentti Kujala, is like a living bridge between Finland, Aalto, and Estonia, Tallinn University of Technology. You're welcome.
Okay, so thank you. So my background is naval architecture, so I of course, my main topic is maritime transport, as you maybe heard from my presentation. And actually, Gulf of Finland is very important for me because I got my professorship because the city of Kotka in 2006. City of Kotka gave money to the, in that time, TKK, that without money of Kotka, I could never have been a professor, I'm most probably. So Gulf of Finland is very important. And in Kotka, we had a Meri-Kotka Research Center, and we had a lot of cooperation between Finland, Estonia, and also Russia. We had this border money, a lot of European Union border money. It was very good money. And of course, now we don't have that money, so it's a pity. But my background is, and I was very active in 2014 in Gulf of Finland here, so we had a very nice trip to St. Petersburg, a very historical trip, very nice things, but good memories about this cooperation. But maybe I want to raise maybe 3 topics. Maybe first one you can guess about this winter navigation, so I'm sure we can do more together, especially Estonia, Finland, maybe Sweden, that how many icebreakers we need together, why every country is thinking how many icebreakers they need, so maybe we can think about what is the most economical and most safety and more environmental friendly way to cooperate. That I know politically it's difficult, but scientifically we can do something. I mean, that's one topic I'm happy to cooperate. And of course, Russia also has icebreakers, so soon when if one day it's possible to continue the work, so I'm very happy to get them in once they behave better way. And second very important topic, nobody is at the moment, not today, but even not in any public literature, is this kind of a oil transport. You know, we have a lot of oil transport still, and nobody knows what kind of a crew we have, what kind of vessels we have. Of course, we know the names, but we should actually make a study together that what are the risks today about this oil accident. We have new type of vessel, new type of crew on board. It's definitely a cooperation and it's related to Russia because they will export oil heavily still in Gulf of Finland, and every day there's big tankers. So it's one important topic. We should cooperate somehow and have a link to Russia. I don't know how we link it, but that's another thing. But even our president a year ago, Sauli Niinistö, who is a very strong character, he said that we can stop all cooperation with Russia, but we have to be worried about oil transport. He's mentioned it in an official president this New Year's speech. So our president will support it, that we do something together to think about oil transport risks. And maybe the third one we discussed was with Robert Apso again, that also we have ministry here, the ministry people. We have done a lot of science, but that's nothing. We have to change science to actions. We have to somehow cooperate that we get science to the political decision makers, and we have been discussing a lot, but there's a lot we can do together. That we have a lot of scientific results, a lot of papers, but how to make that for to scientific to make the decision makers right decision. So 3 topics which I'm happy to continue cooperation. And I said I'm traveling I'm always between Helsinki and Tallinn, so almost all the time, so on a ferry. So I'm between Estonia and Finland. So.
And this last question is far from being rhetoric, and Pentti is actually showing how to convince policymakers. It's by tagging things in terms of money. What does it cost to have more waiting minutes?
Yes.
And if you divide the cost of ship day by number of minutes in a day, then you get several thousands of euros or dollars per each minute what the ship is waiting.
Yeah.
So, as you have now seen, it's a very extraordinary spectrum of people here, and the research is focusing on greatly different timescales, while Hans is modeling things which are starting from milliseconds, I believe, so at least, if not milliseconds, then seconds definitely, perhaps milliseconds.
Milliseconds, yeah.
Then Loretta is looking at coastal changes which happen in hours and days. Pentti is looking at seasons. It's not ice age, fortunately. It's much faster. And then perhaps the longest time scale is represented by Ivo Lapland. And there is a perception widely spread that geology is just about the past. But we have learned in the Baltic Sea Basin that geology can teach us so much about the future. Could you please possibly, as an unexpected and attacking question, how geology could be useful for glimpsing into future?
Well, thanks for this intriguing question. So that when it comes to these environmental aspects and geology is typically somewhere at the side, and the biologist and the hydrologist and water column people get most of the attention, and the geologist, are hiding behind. But I think you get to the right point that the geology is not telling us only what happened in the past, but it also tells us what's happening in the present. And we really need to use our geology knowledge to predict possible scenarios, particularly to the Gulf of Finland area, which is really sensitive to environmental changes and how the nutrient balance could really be changed if we have a big disaster from the oil tanker, or if we have reduced water exchange with the world oceans, and the anoxic conditions are expanding, or we have a higher load of nutrients from the land, again causing the productivity. So the marine ecosystem, including the seafloor, would react to all of that, and we may reach the tipping points from the geological archives that, for example, we have been talking about the phosphorus, and the phosphorus is coming in from the land, and St. Petersburg is bursting into Gulf of Finland, whatever they are bursting there. But if we reach the tipping point, then we can really release huge amounts of phosphorus from the marine sediments, and also these concretions, these iron manganese concretions that are abounded in the seafloor, which suddenly may become not really, which may turn from the potential economic resource towards the environmental hazard. So all these kind of aspects need to be carefully evaluated while really taking best care of this unique resource what we have in our hand.
Absolutely, and we have learned from our geologists that, for example, the lack of oxygen in the Baltic Sea bottom is not a new thing. It has happened many, many times during the lifetime of the Baltic Sea. I don't know whether it comforts you, but if you look into future, then having frequently lack of oxygen in our sea bottom, it's a bug. It's a feature, not a bug. Just a feature of the Baltic Sea. The second longest time scale of things here is actually covered by both Liis Kikas and Kai Mürberg. They are actually making the same thing, which in general could be called as science diplomacy. In old times, in bad old times, in Cold War times, Helsinki Commission was almost a unique channel of communication between the West and the East. So it might happen that we are facing the same situation. I hope it will not be like that, but we have to prepare also against this kind of situation. And scientists are well known as ambassadors of not only their countries, but of the style of thinking which is thought to be reasonable in different countries. So what do you think, both of you, choose in whatever sequence you comment? How could science not cope with the existing situation? How could science improve the existing situation? Or it is too dangerous for scientists who are not experienced in negotiations and high-level policy. Maybe we should get our hands out of policy. What do you think from different perspectives? Yes, ladies first, as always in dangerous places.
It's very, very tricky that you gave me the first word.
It's not a trap, absolutely not a trap.
It kind of sounds like that, because as a representative of a minister, I must say that I'm not in a position to say anything on behalf of Estonian Republic in that sense, differently than our foreign ministry, which is it is, well, as I mentioned already, that actually in the forum of HELCOM work currently, we came to this kind of a soft solution that on the political level we do not engage any like face-to-face meetings or discussions, but still in written form we ask their data, and we include them in development if there are like new documents, new decisions coming, then we will send them in written form our new papers. And as I said, ask for their information. And actually, I must say that last autumn, we managed to receive some input from them regarding their water management details. But we were a bit hesitant of if they were correct data, because they seem too small, too low, the amounts. So we can't validate them now on the political level. So that is the one aspect, that we can ask some maybe technical information, but the correct, is it correct? We can't validate them. And it's very difficult to get now their, as I said, their commitments, that they are willing to commit into making the Baltic Sea environment better. So these commitments should come from the political level. But we are not there yet. So there could be some technical, scientific cooperation possible, but still very difficult on the
Thank you very
level.
much for this information. Just to tell that Estonian Ministry of Foreign Affairs has routinely used scientists as kind of ambassadors. So we have been visiting regularly even countries like Turkmenistan, which are really tough countries, but they are not attacking to their neighbors. That makes difference. And science diplomacy is now picked up on the highest level in European community. The first European Science Diplomacy Conference will take place in 5 weeks in Madrid, just before Christmas in December. So at least the Estonian Foreign Ministry is suggesting unofficially that keep personal relations with fellow scientists. For the case, if things start to become better, we know whom to talk to. Not to simple people from street or just clear extension arms of government, but reasonable people who know what is going on and who could take decent decisions. So this is not said out officially, but this seems to be the policy. And another aspect is that, two other aspects, like Charles Babbage wrote more than 200 years ago, that bad data are better than no data. Yes, I understand there are cheating, there are information attacks, etc., everything is possible, but the point is different. If we provide correct data and adequate interpretations, they do their work. Slowly, like water dropping on stone, there will be a hole after some time. But actually, Kai has been a real science ambassador between our countries. So what's your perspective on those things?
Well, as Liis said, this situation with HELCOM and also with the ICS, where I'm a Finnish delegate, it's very critical, because now Russia is suspended, not removed from this organization, but this suspension time, it's a transition time. We cannot keep them suspended. It's not only economical question, because they are not paying the national contributions, which of course will harm the budget of those institutes. But for example, in the ICS, Russia has said that if they are not taken back, they will resign themselves, and that will be very harmful. That it's very difficult to see that if a country is removed or goes out itself, that it will come back very soon. What about relation? I fully agree that if the situation becomes better, then even a little bit this discussion of environmental question is something which we can start with, because it's somehow neutral. Everybody is interested about the well-being of the Baltic Sea. But still today I have the experience from the late states of the Soviet Union where we could have a relation to come to Soviet Estonia and to Leningrad to keep in contacts. Maybe we were a little bit kept on the eye by the authorities, but as long as we did not talk about politics but did science, I think that there was not so much harm caused to us. But till today, as Tarmo said, that we should keep this networks. It's very difficult because at least I think that I have a lot of contacts, of course, in Russia, but if I would now make some contact with Russian colleagues, I'm afraid that I could cause them a lot of troubles because they would be immediately blamed to be some foreign agent and put to prison maybe to 15 years. So the situation is now much worse than during the Cold War time after 60s, so to say. So I really don't know, and if the situation improves, then we have to unfortunately get the picture, that full picture again, who is still in the science, who has left Russia, who has been forced to do something else for a living and are not maybe going back to science. So we will only meet some ruins of this network which we had still 2 years ago. In this hall, by the way.
Yes, this is a situation, unfortunately, and there is not much we can do in this respect. But still, we are living here not only on latitude 58 and higher, but also in a very eastern latitude. So we can't ignore the situation that we do have a massive, powerful, and almost unpredictable neighbor. In this situation, Kazakhstan has a much worse case. Kazakhstan has two such neighbors. So maybe a good solution is to contact with those guys here and ask how they manage the situation. But okay, going back now closer to the Gulf of Finland situation, we have been thinking here how we could spread the experience and knowledge gathered in the Gulf of Finland science, having in mind that it is extremely variable everywhere, starting from the formal geometry and ending up with old bottom depositions. And here now I am approaching Loretta with a reverted question. We do not have much sandy beaches here in the Gulf of Finland. The longest in Estonia is about 10 kilometers near Narva, and there are very interesting sand formations. Oh, I have again tell the word Russia. In the Russian part of the Gulf of Finland, where slanted fetch effects and waves approaching under very large angle to the shoreline have created instability of shoreline, which is one of the unique things in the world. So Loretta, how your research to open sandy beaches could help us in understanding what happens in the Gulf of Finland sandy beaches?
You know, Tarmo, I'm very surprised that you said that here in Estonia you don't have sandy beaches. So far as I remember, 16 years ago, I was brought to the sandy beach on Aegna Island, where the
that was 200 meters long.
But the sand grain was about that size. So everything depends on the point of view. And you know, the sand is quite interesting substance. It usually goes from one country to other country without looking to the borders. And as we Lithuanians always complain that our sands are going to Latvians, Latvians complain that it's going into the Gulf of Riga and then to the Pärnu, which is already in Estonia. And in Gulf of Finland, also we may see this so similar paths. And here, that sand, which is moving, and actually nowadays with the changing climate conditions are becoming as expensive as gold. We should not forget that in a few years, Lithuania, Latvia, and Estonia might be the perfect place for summer vacations for the people further north, because plus 25 is much better than plus 40 and 50 in Italy. Yeah, so it's, and here, that even if we have short, not we, you, have short stretches of the sand, it should be, we should change our attitude to the sand on the shore. And as you saw in my presentation, that actually even small stretch of the sandy coast is valuable. And valuable for the people, and not only during the summertime. In the winter, it's also valuable because it's very nice just to go and to walk. And in the Gulf of Finland, actually, you don't know, maybe you have some extra resources of the sand which may be reused. And what we say that from the geological point of view, the black sand, it's not bad sand. Yeah, so it's just have some information about what was a few thousand years ago in this area. So we should look into the sand not only in the terms of the sediment transport, but look at it as a future resource in the economical perspectives. I like your question. I can talk about sand age, and I forgot the question. Sorry.
Okay, there will be snack time in very soon, so we shall continue then. But it's clear that sand is an asset, and what I really like from this conference are the attempts of quantifying unquantifiable. Just to provide one parallel, there is some research how to assign monetary value to beaches. They are made in a few locations of the world. I think most notably in Israel, they know that the money is important thing. And typically a 2-kilometer long sandy beach is worth of about 40 millions of turnover of economy connected to this sandy beach. And when you ask $100,000 or euro for replenishing sandy beach, there is no money for that. So in some sense, our understanding is so strongly asymmetric. And I always like the thought that our world is asymmetric. The smartness of people is limited, but foolness is not. We have heard from Pentti today a very nice exercise of estimates of how many icebreakers we need in different countries and regions. And we have also discussion about research vessels. So if you now try to extrapolate your analysis in a rapid way, just in coming 10 seconds, what's your estimate how many research vessels we need in the Baltic Sea area?
We heard a good presentation today about that. So it's a good question because I know in Germany at the moment they are putting a lot of money to make a research vessel that you can research everything. This autonomous shipping, new fuel, icebreaking, that's the future that we need data. So something like that we make a good research vessel that we can do everything on board the vessel. And I don't know, maybe not the number, but the quality is another one. So we can maybe think about, if Germany is making one, maybe we can think about together, think something similar. That next research vessel is that we can study. We can study environment, we can study oceans, but we can also study this kind of ship design type of thing. So maybe the research vessel historically are too limited. So I think that not the amount, but the quality is more important.
Okay, Kai, and then Loretta, please.
Well, just first old anecdote. When I was working in the Finnish Institute of Marine Research for a long time ago, my boss was Professor Pentti Mälkki, and when I got some new computer, because I was doing modeling, he said that I said, I'm very happy with this computer, and he said that don't say it, because immediately you take some more high resolution version out to your model, and next day you come to say to me that again this computer is very slow. So when it comes to the research vessel, I think that it's up to what we are doing, because, for example, in Finland we are now doing quite much this HELCOM monitoring, but of course if we would have a lot of ship time, we would have could have a different research project, and then we could cover easily the whole year with Aranda, or take maybe some smaller vessel to the coastal research. So it's also, so to say, depending what we are doing and what are the resources. So I think 2 vessels would be beneficial, at least for the Baltic Sea, 1 for the open and 1 for the coast, but of course that is not enough. But at least I think 4 or 5 vessels could cover if we are doing the results all around the year with ice, some of them with ice classification and some with not, and some really specified to open sea condition and some with some coastal conditions.
Yes, that's true. There is very little systematic coastal research in the Baltic Sea area. There is a little bit, but not really enough. But Loretta, please.
That's what I wanted to just continue, that Lithuania, with only 90 kilometers coast length with the Baltic Sea, we have 2 research vessels. One belongs to the Klaipėda University, it's a big one, like something similar to, okay, it's not icebreaker, but it's fully equipped with for the geological works, and it spends mostly time even outside the Baltic. But we have the second research vessel, which belongs to the Lithuanian Environmental Ministry, Vėjūnas, which is designed to do monitoring in the Curonian Lagoon, which Arand is not suitable to go to the lagoons. Yes, and even our Mintis is not good to go to the lagoons, so it's. But even that, our catamaran is not good to make in the coastal area. So we still have that gap between 0 to 5 meters depth, and how to solve that problem, which is where is the mostly interesting things happens, especially from the small scale sediment transport. It's like we had that famous experiment in for the sediment transport rate evaluations when our equipment was covered by the sand. So we know that we have enough sand on the Curonian spit, but we still don't know the exact rate of that sediment transport.
Not yet. There is still one person to whom I had a specific question, so I kept specifically with the last. So you won the ERC grant. Congratulations about that. Now the question is twofold. What's your main idea, and whether it is somehow connected to the Baltic Sea problems?
Yeah, so the idea of this ERC is about understanding the sediment transport processes, but also look at what is happening to the soil. I think when we take this hydraulic or coastal perspective, it's very separate from what the geotechnical people think. And the idea is to bring those 2 disciplines together and have a unified framework to understand how sediment is transported, but then also how the the bed is deforming. And there are a couple of important areas where this can be relevant. For example, in Norway we have a lot of landslides impacting our infrastructure, and then it's also there the interaction between the water and the soil, this understanding. But when we come to the coast, it's especially the cross-shore sediment transport where it's relevant, where we have collapsing beaches due to extreme storm events. So I think that's where this project can make a contribution. There's the challenge of having very small scales. On the one side, we have particles which are extremely small. Then all the other current and waves, those effects, they are happening on larger scales. So what we are trying to do is bridge this in our framework, having different models for the different scales that they can interact with each other. So in that sense, we can probably take a bit more short-term and local perspective understanding processes at the Baltic coast as well.
So basically underwater computational morphology.
Yeah, exactly, yeah. And then also specifically driven by extreme sea states. That's what we would like to...
We can provide some extreme sea states to you. As you have seen, significant wave height in the Gulf of Finland, almost 5.8 meters, which was thought to be absolutely impossible. All wave scientists until 2001 was certain that significant wave height never will exceed 4 meters in Gulf of Finland. But you know, the nature didn't care about those things, and now we have well above that level. If it hasn't been too boring, then no questions from the audience, please. Yes, please take a microphone so that those who follow us can also have the question.
All right, thank you. While you guys were on the topic of research vessels, there's one thing I'd like to comment on the amount of how many would you need in different parts of the Baltic or all of the Baltic. Excuse me. The main thing here is, again, if we are in any way successful in future in this TNA, the transnational axis, and able to combine our forces better, we could have several research vessels, all of them with different capacities. One big thing in us getting the new Aranda towards the end of the 80s was that at that time there was a strong shipbuilding industry in Finland, and also Finland had joined the Antarctic Treaty. And that meant that Aranda went to Antarctic 2 times, and she's been many, many times in polar regions when Finland still did serious marine research, which we don't do presently. Anyway, do we need another polar vessel? I think we do, and there would be use for it. So Aranda, or whatever the new ship is, it could be a polar vessel, it could be used for wintertime monitoring in any kind of circumstances that the Baltic may throw at us, and then in the summertime use her in the Arctic for 3-season ice edge work, which she would be very capable of. And in the meanwhile, use different research vessels or even ships of opportunity for offshore and maritime or coastal monitoring. But I would like to ask the panelists another question, if that's okay. Okay, one thing that hasn't come up here yet, we have talked about the sediments and the nutrient loading and whatnot. The fact is that Gulf of Finland is one of the most significant waterways in the world, and a very, very important trade route, especially after 1700 when Peter the Great stamped his hat into the bog at the end of it and decided, okay, the new capital will be here. Every war that has been fought in the Northern Hemisphere has been fought here. And in both world wars, the Gulf of Finland was the most heavily mined sea area in the world. And as a result, we got a multitude of wrecks on the seabed. And many of these wrecks are actually environmentally hazardous. And the work has already begun. It has been up in Helcom, the Helcom submerged. And we are actually, from the start of this year, Syke has been responsible for doing the pre-salvage survey and data gathering of these wrecks, and this is what we're doing. Now we have seen that some malevolent factor has used a ship of opportunity to drag anchor and damage underwater cables and gas pipelines. What we have between us here, between the Naissaar and Porkkala, it's an area which, with a good reason, can be called the Iron Bottom Sound, because there are so many wrecks there. And there are several, for instance, several destroyer wrecks. I just made a quick calculation. One single Mob 36B German destroyer still carries about 35,000 tons of ordnance on board. And this is not, tonnage is the amount of explosives, and it's all packed in projectiles, in steel casings. So the destructive power is really big. And in addition, there's about 300 tons of oil still on board in the bunker tanks. So if somebody would want to cause significant mischief to Estonia and Finland, did just a little bit underwater work, and I know it's quite possible since I have visited personally all of these wrecks, and put up some detonative devices in there. That would be a bang that we will hear here in Tallinn and also in Helsinki, and then everything will be all around. We have sampled that area, for instance. There's a lot of oils in the sediment. Do you see this as any kind of a danger?
Okay, then start from Loretta, then Ivo, then Kai.
I have very short answer, yes. And on the question what to do?
Yeah.
I
didn't ask that. I'm going to spare you that.
Yes.
Yes, Ivo, please.
Yes, I think this is a very important point that you brought up. And we have, the technology is all there. We have all the tools in our hand to do the proper mapping of the seafloor, really to locate what are the hotspots for these kind of environmental concerns, and go down with ROVs and really assess whether there are leakages possible, whether the ammunition or whatever is in these shipwreck is safer or need to be handled. Because, as I said before, we have unique resource what we have to take the good care of. And yes, we need a proper seafloor mapping programs that, in addition to the natural variations, also take good care of these anthropogenic disturbances of the seafloor. And as we have seen with these anchoring drama recently now in the disrupting the pipeline. But we have anchoring in Estonian waters of the Gulf of Finland. There are 15 big tankers every day there, and dragging and vandalizing our unique seafloor. This, as a marine geologist, this really bleeds my heart. And why we are not doing it? Why don't we get our politicians behind it? Because the vessels can be organized, the technology is all there to really take good care of our unique resources. Thanks for bringing this up. This is a very important point.
And the fact is, at least on the Finnish side, this mapping has already been done. The problem is that it's all the data is in the hands of the defensive forces. And due to its sensitivity, it's not public. And whenever we do seafloor mapping on Aranda with our multi-beams or whatever, it's that data is highly sensitive, and everything needs to be okayed by the Navy, and all the data is in safes and so on. But I agree with you. We should really get together a common database where you can see everything. There's actually a room in a cellar somewhere in Finland. I have been in that room. There's a 10-meter wide wall and a complete picture of underwater Gulf of Finland in there. You can even pick out wrecks on that.
Okay.
You're actually allowed to take your cell phones into that room.
That's right, yes. Kai, please.
Well, I think that Rope is completely right. The answer is, of course, yes, that this kind of harm can be used. And the other question is that if it's quite logical if you want to occupy another country, your country is bigger and you have a bigger power in the world. That's unacceptable, but it's logical. But if you just destroy some old wrecks in the sea bottom, it's senseless terrorism. It doesn't lead to anything. Nobody is winning anything from which, so it means that if Russia or any other country will do it, then they are simply desperate, that it's a sign of a ruining country. But they can do it. Yeah.
Yes, and it means that they shouldn't know where the wrecks are.
Yeah.
Loretta had...
just a short comment that
yes.
why on the Lithuanian side we have so small amount of monitoring points, only because it's quite hard to find other places where it's safe to take samples on the soil.
You actually touched a much more general question about open science, open access, open data. Those principles work nicely in a democratic world, but they do not work at all in polarized world. So we as academies of sciences over Europe and chief science advisors to European Commission, we have asked European Commission to switch down the use of open databases for Russia and Belarus. Russia is using European databases for targeting what exactly they bomb. That hasn't been even a response. That's so much about policy making, but we keep pressure. It is complicated. We don't want to close down open science as a principle, but it really doesn't work in a polarized world. But I would like possibly to switch to some more bright topics. Anybody has a question about our bright future?
No. No.
You shouldn't be so pessimistic. Otherwise, I shall ask. That's much worse. If not, then you can now ask each other questions if you wish.
I wish to ask about the bright future
Yes.
for the person from the...
You may ask the audience.
Then it will be not nice questions. For the Ministry from the Climate, do you have any plans how to use here in Estonia that possibility that with the rising atmospheric temperature, this part of the world will become more useful, more suitable for the leisure tourists?
This cool question to the Ministry of Climate, I would say. But actually, regarding coastal tourism, this is a topic that is in between of two ministries, so still it's in the economic ministry as well. So, of course, there might come possibilities, but on the other hand, we still need to make sure that these possibilities are sustainable and they won't mess up our natural resources more. As if we are inviting more tourists here, we give them good possibilities, then yeah, really, we need to see that this part of economy really suits in the nature.
Nice and expensive.
That is actually, yeah, this is one possibility. Yeah.
Wait for microphone, please.
Just a couple of days ago, there was on main national news in Finland that foreign travel to the Saimaa region, which is a big lake in central eastern Finland, it has exploded, and there's so much demand for the coming summer and fall that they just can't meet it. Mm-hmm. And that was actually the same concerns, that it needs to be held sustainable, and all the entrepreneurs in the area agree that yes, we will keep it eco-friendly and very expensive and nice.
Mm-hmm. Yeah, because actually we have the idea of developing a blue economy roadmap in Estonia, and I believe that this coastal tourism and development of coastal tourism is also part of that. It goes partially in there as it's part of blue economy, but sustainable future.
So the coast will be much more valuable asset in the future, and it's absolutely natural because coast is a line object, differently from area, which is an area object. So if you distribute all Estonians over the area, then you get something like 29 persons per square kilometer. But if you put them all on the coastline, then you get almost a continuous row. who was showing that. Yes, I think now it's time for everybody from the panel to prepare maximum 1 minute statement what you think your science could do for building the future which is worth living in. And Kai, you start.
Yes, I think that after these very sad moments, I think that the bright future is that at some time we can start to cooperate again with Russia. Maybe it's 1 year or 100 years, but then science has, and the Baltic Sea science is one of the first key issues which can be done even in bad political conditions, but not during the war. But I'm sure that the scientists are then asked by the governments to do the job, and we have to be prepared. Maybe it's not our generation which will do it, but sometime it will happen, and we have to be ready for that.
Thank you. Okay, then I have to say, Hans is the next.
Okay, bright future.
Yes.
Yeah, we are working with open source software, and what we see is really this benefits a lot of different groups, students, researchers, engineers out there. And so I think where I see a lot of positivity is that open source development, community-based software is helping really everybody, and we do our small part and contribute, but we also see a lot of other people doing that, so that is something I see very positive now and also for the future.
Thank you. Loretta.
And I'm happy that I'm an example of interdisciplinarity, that we can change from one area to other, and I'm really happy that as now I'm working at the institute at the Klaipėda, where mostly packed with the biologists, so I learned that language also, and that what I wish that we would find the way how to translate our language of science, into the more understandable way. So we learn already how to talk with the citizens. So they started to understand what we are willing to say them and what idea we brought to them. But I also willing that politicians would also, okay, I don't believe that they will learn our language, but that we would learn how to translate it and to bring the key messages to them into the understandable way, and that they catch it and they understood what is the value of our knowledge, of our data, and for their decisions.
Absolutely. It's basically rephrasing the position of Groucho Marx, the great entertainer in the United States, who had 2 points. First, he told that before I go out to stage, I have to have something to say. And second, it's the task of entertainer or speaker to ensure that the audience understands the message, not the task of audience. Pentti, please.
Okay, I can continue to Winnie Young presentation. The big data is a thing, and cooperation, because we have been very separate, maritime transport and environment, but as we heard from Min Young, we can put together all the data nowadays. We have environment data, we have bottom data, we have traffic data, we have ship data, we have all, and we have tools to understand better the whole systems together. And together we have to do it, and so that's the bright future, that we know much better what's ongoing on the sea, on sea transport, and what on the sea. We know much better than 20 years ago. We did nothing. We did know nothing. When the vessel left the harbor, we saw them next time 2 months, and we didn't know what happened between the 2 months. But nowadays we know everything.
Thank you.
Good and bad.
And Liis, you may say what, to your understanding, scientists should do to reach the future worth living in.
Well, from my side and from my position, I am just hoping that our Estonian and the other countries, regional HELCOM countries, scientists continue cooperation in research, and we, even though in the HELCOM family we have this not very cooperative partner, the others are still giving their input and all together we can make the Baltic Sea state better. So.
And Aivo has the last word from the panel.
Well, let's see how this goes. Yes, so what makes me really happy about the marine geology in Estonia under spearheading of the Estonian Geological Survey has got some serious wind into its sail over the last couple of years. And this is really encouraging. And this is not the work what is being done in Estonia here, but these are several international collaborations across the Gulf of Finland, across the entire Baltic Sea, and numerous international cruises, not numerous, 2, 3 international cruises have been organized over the past 2 years now, bringing together and really trying to squeeze the interesting science and environmental concerns out of the Gulf of Finland the best we can. And the extra bonus to all that is that we do all excellent science and have our dreams and things that keep us awake during the night. But extra bonus is that we have the young, bright students working for us from Tartu and Tallinn universities, which gives us the assurance that the Estonian marine geology will be in safe hands.
Great. That was a very positive note. Thanks a lot to the panelists. And now the instructions about the evening snack. The general instruction is that come more or less in time, because the few first drinks will be paid by the anonymous taxpayer, and later drinks will be paid by the particular taxpayer who is ordering the drink. Also taxpayers' money. We all are taxpayers. So the place is called Hellhund. Address you have on the program, Big Street 39. If you go out here, you just turn to the left. Then go down, keep going, and look at the left. The name of this pub could be interpreted in great many different ways. If you depending on which word of those two you translate into English. If you translate both words, it's a caressing wolf. If you translate just one word, it could be a very caressing gaming exercise. But it could be also understood as a hunting for the hell. And in this sense, I have an instruction from Winston Churchill, who told somewhere in the times of Second World War, if you have to walk through the hell, just keep going. Have a nice evening.